Hello? 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 For a few seconds I see and then it's turned off. Is it only here? Good morning? Hello? Good morning, everyone. I hope you can hear me. Nice. So good morning. Welcome at GoDataFest Day 3. I'm sorry. Today we're going to have a chance to exchange knowledge, brainstorm, and share some of the good best practices that each one of us is using. My name is Manolis, and I'm going to be the host for the day. I'm going to guide you through the program and introduce all the speakers as we go. If you have any questions, please feel free to reach out to me, or any of my colleagues that have this Xebia data will be able to help you also if I'm not around. A few things about the talk. So each talk is between 30 and 45 minutes, and we reserve some time at the end of the talk for Q&A. We're going to have a lunch break at 12:15 until 1. And after our last talk, which is finishing at 3:30, we'll have the chance to have some drinks together. Finally, I would like to say a big thank you to the partner of the day, which is Databricks. Thank you very much, guys, for being here today. And yeah, let's get started. So let's welcome our first speaker, who is Stefan from Databricks. And he's going to give us a keynote entitled Generation AI.
So just, yeah, okay, good. Oh, I can hear it now. Hello, everyone. My name is Stefan van Wouw. I'm a senior manager for specialist solutions architects at Databricks. Actually, before I was a manager, I was more of a data engineer. And today, I'm actually going to talk a bit more high over about why Databricks thinks that AI is actually finally going to take off and make a big impact, even though we have been doing a lot of machine learning and data science, etc., for the last couple of years. Now it's actually going to have a bit more impact than it used to have. And I will come to the why, but first I will give a quick intro on Databricks for people who are less familiar. Databricks is actually a company that was founded over 13 years ago, actually 10 years ago in 2013. And we're one of the pioneers of the data lakehouse and currently being recognized by Gartner in 2 of the Magic Quadrants, namely the Database Management Systems Quadrant and the Data Science and ML Quadrant. And also, we are the original creators of open source products like Delta Lake, Apache Spark, and MLflow. Actually, Apache Spark is why I originally joined Databricks, because I really like that open source framework. But now we do way more than just Spark. And we actually have grown to over 5,000 people across the globe, with over 10,000 customers in every industry. So back to the topic of this talk, Generation AI. What does it mean, actually, and why now? We believe that actually this is going to be a kind of accelerated period where it's going to finally make a bigger impact. But actually, why now? Actually, this is a quite interesting point that our CEO always makes. Innovations don't become technology revolutions until they're democratized. What does that mean? Take, for example, computing in the 50s. Actually, it already existed in the 50s, but it took a while until at least the 80s, and that's even before my time, till the personal computer actually democratized it to the masses. Similarly, for the internet, was already there in the 70s, And actually only when the web browser came in the 90s, it became democratized, actually making a bigger impact than just, being used for the military or scientific purposes. And then deep learning, around this time, I actually was alive, luckily. And I remember that at that time, when I was at university, one of my friends actually was very focused on deep learning, but he was actually one of the few people who were actually understanding how it worked and what you could do with it and what was the full potential. But now it seems like this whole generative models lift off with, ChatGPT, etc., is actually, showing the masses what AI can really do, and therefore we think that this is going to have a bigger impact than that AI has had till date. At Databricks, actually, our mission is to democratize data and AI. It always has been. And actually, there is a couple of problems or challenges that you have to overcome to truly democratize data and AI. Because in many companies, the systems that are used for data are not the same systems that are used to do AI. On the data side, there's typically, the structured data that is stored in the data warehouse. And on the AI side, we have unstructured data in the data lake. Those two are typically separate and require lots of, data crunching to go back and forth between each of those. And that, of course, takes a lot of extra unnecessary effort. So the lakehouse actually unifies data and AI with one place to actually store the data and one place to actually govern who has access to it, what are the permissions, do auditing, lineage, etc. And then around it, there are many different tools that you can actually use to get value out of this data. And then Databricks was actually the one who coined this term, the lakehouse, and pioneered it with the Databricks Lakehouse platform. And our solution to the lakehouse, so more like if you go like one level deeper into implementation, is to actually have Delta Lake as the one data format to store data at scale, query it at scale at a cost-effective manner. Unity Catalog is the way to actually govern your data across all clouds. And then we have different product lines which actually help you get value out of your data based on what your business use case is. So for example, for data warehousing use cases, there's Databricks SQL. For AI and ML use cases in general, there's Lakehouse AI. And then there's different, more technical products, such as Databricks Workflows and Delta Live Tables, which actually try to reduce the time that you spend on, ETL, on data wrangling, etc. Make your life easier so that you can actually spend more time on actually getting the business use case implemented. Databricks Workflows is more focused on like a control flow approach, like running any production job that you would typically do. And then the Delta Live Tables is more focused on defining in a more like data flow manner what operations should be done on your data without having to specify where those operations are actually executed, how they're parallelized, how they're retried, etc. when something goes wrong. And it also allows you to either do batch or streaming with the same API. Having said that, actually Databricks is taking our mission to democratize data and AI to the next level. And what makes this possible? Actually, what makes this possible is this rise of the large language models and generative AI in general. And we actually want to democratize AI, data and AI further in two areas. One area is the data. Actually, more people, that not just the technical users, should be able to use the company's data to make business decisions, implement their use case, and actually get more value out of it. And secondly, every company should be able to integrate AI into their products. So if we go to the first one on the data side first, there's this quote from Andrej Karpathy that the hottest new programming language is actually English. So what does he mean by that? Actually, that with the rise of LLMs, it's actually technically possible to query data using natural language. Because before this LLM revolution, so to speak, this was only possible by technical users using a programming language like Python, SQL, Scala, etc. But now, actually, because of the rise of LLMs, it in theory is possible to widen this reach to the entire enterprise. But of course, that's very easily said in theory. And what many companies have tried is let's just naively add an LLM assistant, and then that will, solve this problem. Well, actually, that doesn't work. And that's what we believe at Databricks. And there are many clever people, way more clever than me in this topic, that have backed up this claim. And the main reason for this is that every organization has very specific data, jargon, organizational structure, etc., that actually even experts that might spend years to fully understand. You might remember your first day at a new job. People are using slang, meaning different things. You don't know what they're talking about. In your previous company, the same term actually meant something completely different. Actually, at Databricks, we are uniquely empowered to make use of the data that our customers entrust us, and specifically only your data in your workspace. So not, sharing data of different customers, etc. To power what we call Lakehouse IQ, which you could a very high level say is like an AI-powered knowledge engine building on Unity Catalog. This actually understands context, is highly accurate, secure, and privacy preserving, and is actually already integrated in the product in different ways. Like, for example, if you search, it actually can learn like your company-specific terminology to help you find better results. Or if you're actually a technical user, there's the Databricks Assistant, which helps you generate, pieces of code, debug code, etc. When you're actually working on the product. And we're continuously expanding this to new areas to make it easier and easier for both technical and non-technical users to start making sense of their data and getting value out of it. So that's the data side. So it's basically focused on, democratizing the data to every employee. Then on the AI side, democratizing AI into every of our customers' products. It's actually about building machine learning models, right? And how you manage them and implement them, monitor them, etc. And we actually strongly believe that your AI and your data is what will set you apart. For a couple of reasons, which I will go into a bit later. But basically, in order to enable this, we actually are the first unified lakehouse platform that puts AI not just like in a box aside, but actually integrates this with governance and data pipelines, etc., end to end. So, you can actually do your data collection and preparation, as well as, building a model from scratch or reusing existing models from the Databricks marketplace, and then actually deploy them to production, and then monitor the performance, all kind of being governed with a single governance layer that's used across everything, called Unity Catalog. And actually, since this summer, we have actually put a lot of effort to also optimize this for generative AI. So specifically, more on the LLM side of things, to also be a good platform to actually support you building these LLM-based models. But you might ask, okay, you have this platform. Why do you actually want to own your own model? Because if I just, use a SaaS-based one, I don't need this entire platform. I can just use this SaaS-based one, right? So actually, there's 3 reasons for this. First, control. If your model is built based on your own data, you actually own the intellectual property, and that's what sets you apart. Typically, the data is what sets you apart. That's actually your competitive advantage that other companies don't have access to, compared to, let's say, a general model that's trained on Wikipedia. Everyone has access to Wikipedia data, for example. And second, it's actually, there's lots of privacy concern and confidentiality concerns around sharing data with such a general model. But if you build your own, then actually you don't have that concern, because you can control what data goes in, and you also don't have to share that data with anyone else. And then actually it can be cheaper to actually train your own model, and we will show you how that's done. So how does Databricks actually provide this capability all of a sudden with generative AI? Actually, we acquired Mosaic ML last summer, and this is actually a company that solely focuses on getting the world-class best platform to build your generative AI models. And since we acquired them, they're actually becoming part of the product known as Databricks Mosaic ML for now. It actually allows you to train and deploy generative AI models on your data in a secure environment in a cost-effective manner. And combining what we already had with general ML capabilities and everything else I covered, plus this addition of the focus on generative AI, we actually believe that Databricks Lakehouse is the best platform to build, train, deploy, manage generative models in addition to regular machine learning. So in summary, that actually summarizes 2 areas where we actually want to help democratize data and AI further. On one hand, with Lakehouse IQ, democratize the data to more employees, also more less technical users. And on the other hand, actually allow every company to build their own AI into their products with Lakehouse AI and Databricks Mosaic ML. So that's kind of like the AI side of things, and that's always like the cool part. But me with the data engineering background, I really like this statement. Your AI is only as good as your data. The saying of garbage in, garbage out, that's still true, right? So you can have super cool ways of actually, implementing a model, but if your data quality is not up to par, like what accuracy are you going to get? Not a lot. So actually, that's why we're actually focusing as well in the 2 later sessions today on Delta Lake and Unity Catalog, and specifically on the Delta Lake side on the Delta Live tables. But I will first give a brief on Delta Lake and Unity Catalog before I wrap up. On the Delta Lake side, this is actually the lakehouse format to store all your data and query your data at scale in a cost-effective manner. That's what we chose to be kind of the lakehouse format for Databricks. But of course, there are many other formats out there, like Hoodie and Iceberg, and all of them have their momentum and different tools that actually prefer to work with one of those 3. But that actually creates unnecessary silos again, and that's actually something that we wanted to avoid by, unifying, the data solutions in the lakehouse. There are specific connectors or libraries that only work with specific formats very well, and the others not so much. So then again, you get back and forth copy of data, etc. But actually, what they differ in is actually not the data, but the metadata. So it's about, what file is stored where, what are the statistics, etc. And under the hood, they're all using plain Parquet to store the actual data. So the petabytes of data is in Parquet. The metadata is maybe a couple of gigabytes, depending on how much that's stored. So we actually now introduced Uniform as part of Delta Lake, which actually allows you to generate this metadata of the other formats on the fly. And therefore, this will break these silos, and you will still be able to use all of these different tools. For example, if you want to use one that's more compatible with Iceberg, you simply generate the metadata for Iceberg, so that you can, so that you don't have to copy the data unnecessarily, but still can use all the tools. Then quickly going to Unity Catalog to just give an overview of that for people who are less familiar. What problem does Unity Catalog solve? The governance problem. In big organizations, there are all kind of governance requirements, financial institutions even more so, that, only certain people should access the data. There should be lineage, who change what, when, how, etc. And by using disparate set of tools, like a data lake, a data warehouse, separate systems and frameworks for machine learning, separate systems and services for BI workloads, the IT operations are always tasked with trying to sync these, government rules across and implementing them separately, creating a big headache. This just creates a fragmented view, and adds a lot of overhead. So actually with Databricks Unity Catalog, what it solves is actually one unified way for governance, not only across data, but also across AI. You can see that on the right, it's not just files and tables, but it's also notebook dashboards, and maybe most important of all, it can also govern machine learning models, doing access control, lineage, auditing, monitoring, sharing, etc. And this is actually taking a lot of extra effort away by just having one solution to rule them all, so to speak. So as I said, we're actually going to focus a bit more on two of these topics later this morning. First, Kamal will actually, my colleague Kamal who's in the back, he will actually go a bit deeper into what Unity Catalog is and show you around. And then my other colleague, Givansh, who's drinking his coffee or espresso, there, is going to focus more on delta live tables, because we also believe that like delta live tables can actually reduce a lot of time that you spend on ETL, and then you can actually use that time somewhere else, for example, to actually get a use case implemented that adds business value. So with that, I would like to thank you for inviting me to speak here today. And then I think there's time for 1 or 2 questions.
Thank you, Stefan. Are there any questions for our speaker? Yeah, sure.
In the Unity Catalog slide, you have mentioned notebooks as well. What do you mean by governing notebooks with Unity Catalog? Can I also access the same notebook in any other environment? I know like tables and data can be governed, but what do you mean by notebooks?
I think it's mainly about the access control, but Kamal will be able to show you that.
Okay.
So I hope that helps.
Hi, since the topic was Gen AI, my question is, like Dolly is one of the models, right? But do you have plans of making some covered layers of other LLMs on Databricks?
I think there is now, like, I'm by no means an expert on this LLM specifics, but actually there's, a couple of standard models that are commonly used and that you can actually use from the Databricks marketplace.
From market, yeah.
And then kind of tune for your use case.
Oh, but I understand that you can onboard kind of all models to catalog in general, but also interesting like the strategy if Databricks plans to after train and fine tune how some other companies are doing. But I guess I need to connect with somebody else.
I saw Kivans,
you
know more.
See that maybe we connect.
I mean, we will gonna have support for calling the APIs of, for instance, OpenGPT or other model providers as well, and anything that you build and model and outlaw, you can also serve it.
Yeah.
But we also have plans around Mosaic ML to improve it, and because it's really efficient in training these LLM models, but it will be possible. Yeah.
Good.
Short answer, it will be possible. Thank you.
Yeah, I've also a question. I know the talk was about AI, Gen AI, but as Unity is pretty much in every slide that you have shown, or in a lot of slides that Databricks is showing nowadays, I really want to ask you a managerial question. So what is your confidence level that Unity works at scale for these kind of purposes? Because we are, as we speak, implementing Unity. We want to do it at a large scale, but we really need your confidence vote because we haven't proven it yet. So we're really looking forward to, what do you think is the maturity of Unity?
I think, so actually, the maturity of Unity, I think is mature enough that actually our major customers are actually migrating to it. So that answers part of the question. I think at scale, is it like, do you mean like cross-region or stuff like that, or more like within a region?
Basically for all data workloads in a large bank.
Mm-hmm. Yeah, I think so.
Yeah?
Yeah, because we have many high-level customers who are using Unity Catalog. It's not about scale time, it's even much more efficient than high-level store that currently being used. Yeah. And lots of features are built on top of Unity Catalog, so it's pretty mature and we have lots of investments in Unity Catalog. Without those features, you would not even able to use lots of features like predictive optimization, or for instance, materialized view, we're going to talk about it. And if you are talking about number of users being supported, in a bank, for instance, you may need 10,000 users in an AD group, so you need to see, and these kind of things you can increase. There is some current limit is 10,000, but you can increase it to, for instance, 25,000 because your SA, you can just create a place and engineers can easily I can say it's highly scalable, you can use it, but even there are some improvements coming.
Okay, thank you.
Can I have a quick follow-up question on that? Sorry, I don't mean to hammer on this one, but your answer I found quite interesting. If it's already being used at scale, very blatantly, can you put us in contact with one of your consumers that have deployed it at scale?
Private label customers and games?
Yes.
Yeah, I mean, based on your customer, so depending on your customer, you will gonna have an SA assigned with you, working with you together, right? So then he can arrange these kind of things. I mean, I cannot just put
Sure.
blindly
Sure.
a customer, but for instance, you are working with Xpeng, and possibly we will gonna have context there,
Okay.
and then we can plan that one. So,
Okay. All right.
you know,
Second-
Unity Catalog is the way to go.
So that's part of my second question is essentially, is it on a critical path? Do we need to go to Unity Catalog? Is it optional? Or
It's optional,
But?
but many of the features really built with Unity Catalog because we really want to secure how people are accessing it, auditing, and sharing data between different workspaces, just having one scheme, and for instance, predictive optimization, which is really critical, right? Because we really want to use, for instance, we don't want you to deal with partitioning, vacuuming, optimizing, because they can create some conflicts. So for that reason, many of the features are built on Unity. We recommend our customers to use Unity.
Okay.
But it doesn't mean that you cannot use Hive Meta Store. But I highly recommend you to use.
Okay. Thank you.
So I think that there's a lot of interest about Unity Catalog, and probably Kamal now is going to help us answer some of our questions, who's going to give a deep dive into Databricks Unity Catalog. Welcome, Kamal.
The laptop. Hello. Am I audible? Yeah, I think. Yeah, hello, morning, everyone. Thanks, Stephen, for setting up the premise, and I see a lot of interest in Unity Catalog. So this session will be mostly on Unity Catalog. We will try to deep dive into some of the topics. May not be possible to deep dive into all the topics of Unity Catalog. It's quite, considering the time constraint, we will try to take some questions around Unity Catalog, and let's see how it goes. Yeah. Just a quick introduction for myself. My name is Kamalendu. You can call me Kamal. I'm a special solution architect at Databricks, mostly working with data warehousing, migrations, and data governance project. Before that, I have worked with Hausberger, Pontanel, basically Just Eat Takeaway Now, Oracle, and Accenture, and I'm a DBT fan. So if you guys, someone using DBT, cheers to them. Yeah. Yeah, so the agenda for today is quick introduction of Unity Catalog, how it integrates with different cloud providers, how do you register your data with Unity Catalog, how do you secure it, and then how do you search and audit and lineage. And then I will discuss about different architectural patterns that you can implement with Unity Catalog. And last but not the least, and the most complex one is like, how to upgrade to Unity Catalog. And if time permits, we will try to do a quick demo, and then we will take some Q&A. Same topic that Stephen already described, that why Unity Catalog. So Unity Catalog is a unified governance for your data and AI. Generally, when we say or when we talk about data governance, we mainly talk about how to implement data contract, how to put permissions, how to set all those things, but we hardly talk about how you will govern your AI models, or how do you govern your file system in the S3 cloud storage. You might have been directly providing access, or you might be using credential pass-through using Spark clusters to provide those accesses, but those are really not great, and those are really doesn't have any fine-grained access control. So we will talk about those things. So what Unity Catalog provides you: access control, lineage, discovery, monitoring, auditing, and sharing. And by the name Unity Catalog, some who are not much familiar with Unity Catalog thinks about it as yet another cataloging tool. It's not a cataloging tool, it's a data governance tool. And it can cover a lot of, almost all of your workloads, kind of BI, data warehousing, data engineering, streaming, data science, and ML. It can connect to any of the open source interfaces like, or open source or managed open source interfaces like Athena, EMR, Trino, and Presto. Almost all the cloud providers, like the most important three ones, Azure, S3, and GCP are supported. We now have something called Catalog Federation. So if you are already having Hive Metastore or AWS Glue Catalog, you can import into Unity Catalog and govern from a single place. And we also have Data Federation, where you can connect any of your separate data warehouses or databases to Unity Catalog. So as of now, we support Redshift, Snowflake, BigQuery, MySQL, Azure Synapse Analytics, Postgres, and SQL Server. In coming months, we will have Oracle and Teradata as well. So if you are already using those products, you can directly connect Unity Catalog to those systems and govern it from one place. Before going to discuss about how it integrates with cloud provider, just a quick revision of how cloud architecture looks like in different cloud providers. So in Azure, you will have Azure account at AD tenant level, and that will connect to your Databricks account. And under AD tenant, you will have multiple subscription, and each of the subscription can have one or more workspaces, right? Same goes for AWS and GCP, slight difference. So for AWS, you will have one of your organizational unit, which can have multiple AWS account, and each of the AWS account will be connected to Databricks account, and you can have one or more workspaces in AWS account. Same thing goes for GCP. It's exactly similar. So you have different entitlement and project and multiple workspaces connected to each of the projects. Just the summary of what we discussed. So at AWS, you will have an account. An account will have multiple region, or a region can have multiple accounts, and then you will have multiple S3 buckets, and you can have multiple IAM roles. So these are the analogous relation between each of the items in Unity Catalog. So account connects to account. Metastore represents a region. Catalog represents an account. You can have multiple accounts. And storage location represents your S3 buckets. And credential represents your IAM role. Similar things for Azure and GCP. Moving to the next. Yeah, this is quite important thing for Unity Catalog. You have to understand, like in Unity Catalog, there are 4 kinds of roles available. One is the account admin. It has the highest privilege. Use it wisely. And you need someone from if you're in Azure, you need someone from your Azure AD group to be part of this account admin role. It can create workspace, configure metastores. It can create groups, everything. So basically, it is the highest privilege, and use it wisely. Next comes the Metastore admin group. Metastore admin is level lower than account admin group. It can create all this catalog, external location, share, and all those things. Again, we recommend to use to give this permission to someone who was from your central government team or platform operations team, or delegate to your domain team if you are trying to build something like data mesh kind of architecture. So each domain can have one admin and can become a part of Metastore admin group. Then we have workspace admin group. Workspace admin basically controls the workspace. So you can have multiple workspace, and each of the workspace can be governed by a different person or different groups. Workspace admin group can be your regular service principal for audits and all those things. And then finally, you will have a data owner group who will actually the data, own the product of the workspace. So for example, if you are building something like some use cases for, let's say, retail management, you will have a separate workspace for retail management, and there is one person who will, under the retail, who will, let's say, take care of the marketing, take care of the other stuff. So you will have different data products, and each of them can have a different data group, different owner of data. And this is mainly recommended for your BU government team, governance team, or central government team can also manage if you are going into centralized governance model. So talking about governance model, we generally see these two kind of governance model. One is quite centralized, where you will have one central team to provide all of your governance, permission, access, everything. And then in more of a data mesh kind of architecture, we see data distributed governance, where you provide freedom to your domain team to define the governance, right? And also it can be a collaboration of both of them. In data mesh architecture also, we have seen hub and spoke model, so where hub controls the governance and spoke uses them. So you can basically combine both of them. So that was just a quick review or quick introduction of how Unity Catalog is set up. And so the next question is, how do you bring your data to Unity Catalog, right? So before moving to that, there are two different fundamental concepts that we have now in Unity Catalog. One, when you work with file-based systems, for example, those kind of data lake kind of systems, for example, we now have Uniformat, so it can connect to any of your Apache Hudi or Iceberg format or Delta Lake. And you can also have your databases connected to Unity Catalog. So there are some concepts, there are some glossaries that you have to understand. So when working with file-based data sources, what does credential means? Credential means a permission which provides you access to your cloud storage. External location refers to a location in your cloud storage. There are two types of table if you work with file-based system, called managed and external table. Let me clarify that this managed and external table is not similar to what you saw in any databases. Generally, people think that external tables are not performant. It's not true. External table and managed table have exactly same performance in Databricks. We don't differentiate between them. Only difference that we have is managed table is managed by Unity Catalog, so we can do some kind of automated stuff on those tables. But if you have external tables, as of now, Unity Catalog will not be able to do some automated auto optimization, auto compaction, all those things in your external tables. We recently have added volumes. Volumes is quite useful for your machine learning and AI use cases. You can store any kind of unstructured data like files, PDF, GIFs, audio, video, anything you can store in volume, and you can still have access control over that. And on the databases side, it's quite simple JDBC connection to any of your databases. You can still govern the items of the databases from the Unity Catalog. We call them as foreign catalogs. So let me show you how it's done. So this is something which is called query federation. So you will have Databricks Unity Catalog at the center, and you can connect any of these SQL Server, MySQL, Redshift, Postgres, Snowflake, anything. So how you do it, you basically define something called foreign catalog. If you can see the syntax, you can just create foreign catalog using a connection. You define the connection name. It's a JDBC supported connection. And you can then, once it is connected, you can select star or you can select the data from Databricks for your any other external databases, right? So why it is important? It is important to have a unified picture of your data lineage and data governance. So for example, if you are doing a lot of pre-processing in some stuff that is outside Databricks, let's say you're doing something in SQL Server, you're doing something in Snowflake, and then you are bringing the data into Databricks. So without this, you will have the lineage only of the Databricks, but if you do that, then you can see that exactly from where your source data is coming in. So this is quite powerful for, useful for lineage, and you can also govern those objects. We do intelligent push down as of now for any queries that you send it to these external or foreign catalogs. We have materialized view, so if you feel that you are frequently using some data, you can create materialized view out of these foreign catalogs in Databricks. And this is quite quite a slide where we discuss about how exactly your control flow goes when you query something through Unity Catalog. This is for file-based. I'll show you after how it goes for the databases. So let's imagine as a user, you send a query or you write something in Python or Scala. So how does it checks which kind of access you have and how does it access the data, right? So if you see the control flow, on the first step, it will send the query to the cluster or SQL warehouses. It will then be parsed and checked for the namespace and metadata and the grants. So that second step will go to Unity Catalog. It then verifies whether the names that you have provided for the data objects like table or the views are correct, or you have the proper grants. If you don't have, then you will get error out of it. And let's say you have the proper grants, then the Unity Catalog will translate those grants into your AWS IAM role or Azure Managed Identity or GCP service account. That actually queries your external locations, basically your storage. So user credentials are not directly used to access this storage location. It will always be through these roles that you have already defined in Unity Catalog. And if it finds that, these objects exist in that, it will transfer those file paths with temporary scope down tokens. These tokens will be again passed to the clusters with the path, and then the cluster requests the data which is being inquired by the user, and then finally returns the data. Once the data is on the cluster, it will enforce the policies that you have defined on the data, like row level security and all those stuff, and then finally you will get the data. So basically the whole process is quite secured that only predefined user roles can access the data. Your user will not have a direct access to any data. It will go always via this IAM role. And we also audit everything that user is trying to do in an audit log. So you can have a look on the audits, like who is trying to access what kind of data. You will have all these things. I will discuss about the audit log in the later slides in more detail. Same thing for the external catalogs, like the foreign catalogs. Everything remains same from this one, except the fact that it is connected through JDBC, and the username and password that you define in JDBC will connect to that database. Yeah.
The JDBC, what kind of authentication methods do we have? Is it username, password?
As of now, I think it's password, but I think there are plans to support, I think, OAuth or something like that. But as of now, I think it's username, password. Yeah, so how does your workspace looks like after you enable Unity Catalog? So if you are not using Unity Catalog, you might be having something called Hive Metastore as of now. And under Hive Metastore, you will have a default database and some other tables on this database or some other databases, right? So once you enable Unity Catalog and you connect a foreign catalog, so that will also come under this same Data Explorer tab, where you will have foreign catalogs, and the catalogs that you define within the Unity Catalog will also come. Foreign catalog will have foreign schema and foreign tables, and the catalogs that are native to Unity Catalog will have your volumes, model, function, views, managed tables, external tables, all those things. And you can query using these syntaxes. It's a 3 namespace format, so you need to provide your catalog name, dot schema name or database name, dot table name or view name. So this is what it looks like when you have this Unity Catalog enabled in your workspaces. Just again the same thing with a more summarized view. So basically, one Unity Catalog will have one metastore, that is per region one metastore we support. And under that metastore, you can have as many as catalogs. So for example, in this, if you see, the schema 1 is kind of in a different location in a managed bucket, but catalog 2 is in a different bucket, and schema 3 is in a different bucket. So basically, you can define as many as catalogs or schemas you want. I think the limit is around 5,000, but it's a soft limit. And then you can have different locations attached to them. So your data for each business unit will be segregated, or you can say it is isolated. It is not that all of your data sits in a single location. You can define as many as combination with schema and catalog and have separate location attached to them. And this is how the operations, like access operation happens. So basically, we can have multiple ACL trees for the same user. So for example, in this case, user wants to write something, and 2 different locations. One is external location and another is a managed one. And let's say you have only provided select permission, this query will fail for this user. But if that user has a permission to read write in volumes or any other external location, this query will pass through. So this basically shows you can have multiple access control for a single user on different kinds of different kinds of object at the Unity catalog. And moving to the next one is something which is quite new. It's in public preview. It's called volumes. So in volumes, basically we define a POSIX format external location, which is again your cloud storage. But this will be treated as a file storage where you can use or you can upload any unstructured data like image, audio, video, PDF, anything. These are mainly used for machine learning and AI kind of workloads where you maybe want to parse some PDF or generate some text based on some audio, video, all those things. This was quite a new thing. We can also have a lineage out of this thing. So imagine if you have a model which is kind of reading some PDFs or parsing some audio, video, and then trying to provide you some feedback, we can have that lineage as well. Yeah, this is again kind of how you define access basically. So if you can see here, I have a cloud storage location, and then there are three different locations, and I have tables and volume. So volumes can again be managed and external, similar to what table can be managed and external. Again, there is no performance degradation between external and managed. Only difference is that managed is kind of governed by Unity Catalog, and we can do automated stuff on the managed one, but we cannot do automated stuff on the external one. So that is more about bringing your data, right? And the next topic is how, once your data is in, how do you secure it, right? So this is an overview of pre-Unity and post-Unity, your workflow structure, a workspace structure. So pre-Unity, you used to have multiple workspaces, and the user management, metastore, access control, cluster warehouses were sitting within the workspace. So, and if let's say if you have multiple workspaces, you have to do similar stuff for each of the workspaces. So we have some customers where they use 300 to 400 workspaces. And imagine if you have to manage 300 to 400 workspaces individually, it will be a nightmare, right? So what we do is that we take out the user management, metastore, access control out of those workspaces, and we put it in a centralized Unity catalog. And the workspace level will only have clusters and warehouses. So the domain team just have to worry about their workload, not worry about user management. It is done by the Unity catalog. It is like an example of how you provide grants. It's same plain SQL, like how you use in any other databases. You provide grants using ANSI SQL DCL commands, or from the UI, or you can do it from the API as well. So for example, here it's a grant of a permission. For example, select, it can have select, modify, and all privileges. This is the data object that you want to govern, and then this is the group or a user that you want to provide the access. This is also quite interesting, row level and column level masking, row level security and column level masking. So it's quite popular in other data warehousing world, right? Where you want to provide access to certain rows to certain users, for example, based on location or based on business groups. So basically how it works is you define a function, you put the criteria. For example, if the member is admin, then only it can access the US region data, and you apply this filter to a table. So for example, in this case, I am defining a function called US filter, and then I am applying this filter to a sales tables. So anytime someone queries this table, if he or she is not from the US, he will or she will not be able to see the US data. It can get only, that person can get only the data which are non-US. You can apply n number of row levels functions to the table. You can use multiple conditions in that. So for example, let's say you try to say the user should be from US and from a particular BU, then only he or she can access. So you can define more complex functions. Same thing for masking. This masking is not for encryption. There is a confusion around like what is encryption, what is masking. So encryption is something like when you encrypt data at rest. That is a different technology. We also do that, but this is more of a masking where you mask the data based on user profile. So for example, if I'm not a user from finance, I should not see the salary of any other user, any other employee in my organization, right? So you can apply those kind of masking in this. You can also have encryption, but that comes in a different technology, you need to use some kind of encryption keys, encryption libraries. So don't confuse with encryption with masking. Masking is more of an on-the-fly process where you want to hide data for a particular set of users. And this is how, once you have Unity Catalog, you have multiple workspaces. Sample structure, it looks like this. So in this example, I have catalogs based on my SDLC environment. So if you think of SDLC environment, you generally have dev, prod, QA. So you can have individual catalogs for individual stages or individual environments. You can also have catalogs for different business units. So in this case, let's say BU1 is having their own catalogs. And then you can divide further BU into their own environments. So basically you can have any combination of catalogs based on your business unit or your domain and your SDLC environment, and then tie up those to multiple workspaces. So it's a many-to-many relationship. Many catalogs can be part of many catalogs. So you have to provide permission to which catalog can be accessed from which workspaces. We also have something called catalog binding. So if you do that, only that workspace can access that catalog. So for example, there is a separate workspace for finance team, and you want to have very rigid control of finance data set only to the finance workspace. You can bind that catalog to that workspace, and no one else will be able to use that catalog. And same thing on the access side. So let's say you have a lot of different groups of users. You can assign access based on their use case. So it's kind of a many-to-many relationship on catalog, workspace, and groups. So whatever we are talking about, all these things can be done using APIs and Terraform. You can use Databricks REST APIs and Terraform in conjunction to implement all these things. This is just a way to automate your stuff. Once you are, once you decide that you want to move to Unity Catalog, you can use Terraforms to build the whole infra. So we discussed about how to get data, how to secure data. Now the question comes, how do I use that data, right? How do I use lineage, or how do I search what I have done? So basically, I mostly previously worked with financial and banking industries, and there was quite rigid regulation of, when the ECB or any central bank comes and say, okay, you decided that this is going to be the interest rate, right? How did you decide it? How those figures came into picture, right? So in that case, you definitely have to show them exact lineage, from the source system to the end product. And that is where the lineage comes quite handy. Apart from financial industry, there are a lot of regulations on pharma about lineage. So you can use that lineage things for all those kind of stuff. We have something called discovery. So you can do tag-based discovery or context comment-based discovery. And then obviously there is observability, tracking down who is doing what and all those stuff. So Unity Catalog auto captures your lineage, and someone asked what is the notebook that Unity Catalog governs? So it's basically, it tracks down this table is generated by which notebook, or which notebook is accessing this table. So all those kind of things. So we try to leverage the lineage from the source. Let's imagine if you have a transactional system in SQL Server, right? And you connect that SQL Server as a foreign catalog in Unity Catalog, so we can actually see the data which is coming from SQL Server to your dashboard. So we will show the dashboard as well as part of lineage. So basically it can cover lineage from your source to the end product with the column level lineage. That is quite important. So it's not only table level, it's a column level lineage. You can see each and individual columns. This is what I was talking about, tag-based search. So if you use tags to tag your data items, for example, PIA data or sensitive data, you can use tags to search, and you can use tags to maybe restrict some kind of access to those things. That's why we say that it's not only Unity Catalog is not only about your data, but also about your AI. So imagine if you have some models which generate some kind of sensitive prediction, you can tag them and hide them from the users. And once you are doing with all those discovery, you also want to audit the data, right? Who is accessing what? So we have something called system tables. System tables is kind of metadata of all the Unity Catalog tables. So basically, if you want to see what all tables are there in sales catalog. You can use this kind of tables, for example, system.information schema.tables. You want to know who has accessed this, so who has access to this table, you can use table privilege table to see the data access. If you want to see when is the table last updated or when is it last created or dropped, you can see from this tables called information schema.table. And if you want to know the owner, you can also see from the schema the table owner. So these are all available as GA. We have extended it to have few more audit logs, which is in public preview. So for example, you want to see who has accessed this table most in last 7 days or maybe in last 100 days, right? So you can see the frequent users. You want to know someone might have deleted some table, you can use this query, which is from a system called operational data called audit logs to know who has deleted the table. You want to understand who has access in last 24 hours, that can be also possible, and the most frequent users, you can also get this from audit logs. So audit log table is basically the logs that you used to get in API. Now you get it in a table format, so it's quite handy and quite useful to use. Billing, it's a kind of hot topic with everyone. Like, you want to understand the cost control and how much Databricks is costing to you. So you can use this billing logs table. It will show you daily trend of your DBU consumption. It can show you DBU consumption based on per SKU. So basically, if you are using different services from Databricks like data warehouse, clusters, DLT, it can show you which item is costing you how much. And you may also want to know, who are the top 10 users that are consuming most of my resources. So you can get that as well. And you can also find out the unoptimized jobs that is maybe costing you thousands of dollars per day. So find out those jobs and try to optimize those. And then we have the lineage data. So basically the lineage that you can get in as a table format as well. So it's a hierarchy of data. So basically, if you think of parent-child relationship, so the data is stored in the hierarchical format. You can get the data as lineage data as table, and then you can use that data to connect to some other, let's say, catalog environments. But that can also be done using API. So if you think of enterprise-wide catalog like Colibra or Alation, you can connect that to Unity Catalog. So for example, you are doing a lot of stuff in Databricks, but that is not the end of your organizational IT. Right? You do a lot of stuff before Databricks and you do a lot of stuff after Databricks. So you can connect the whole thing, Databricks lineage, to your enterprise catalogs like Colibra, and you can see the whole lineage or access control from Colibra. So Colibra, actually they are planning to launch something called Colibra Protect. And what you can do in that is you define the data contracts in Colibra Protect, and that will be pushed down to Unity Catalog. So you can again have a unified place for your data contracts. Yeah, we discussed a lot about how things are done in Unity Catalog and all those things. So basically, how the architecture, what kind of architectural patterns that you want to follow, right? So we will discuss mostly 3 types. The most important one, the first one is multi-region or multi-cloud. You can think of like that kind of data mesh, not data mesh, but kind of. So let's say your organization is spread across multiple regions. So you can have one metastore per region, and you can connect all those 3 metastore using delta sharing. If time permits, we will discuss about delta sharing, but just for a summary, it's an open data sharing protocol, and it can connect all those 3 different clouds, and you can share data across clouds regions. And each region can have multiple workspace and multiple catalogs and all those things. Next is a single cloud region, but software development lifecycle. If you think from that perspective, you can have one Unity Catalog metastore. You can have multiple catalogs for different environments, dev, QA, prod, stage, whatnot. And you can have different workspaces for different environments, and you can, transient from one stage to another stage, and all of your data still sits within one Unity Catalog. Next is kind of like how you define your workload. So for example, you have, let's say, some clusters in user isolation mode, which supports only SQL and Python. Some clusters can have multiple single user mode, so which supports most of the languages, and then you have SQL warehouses, right? So all of them can sit in a single catalog, but then all of them does a different kind of work. So for example, you might be using single user mode cluster, Scala or R for some of your data science workload, SQL and Python for data engineering and streaming workload, and SQL warehouses for data warehousing workload. You can have all of these three combination in a single workspace that connects to Unity Catalog. So you can have a single workspace model as well. So these are like kind of how Unity Catalog works. But the main question or the main challenges that you generally come across, or we see a lot of customers asking us, like, how do we upgrade to Unity Catalog, and what is our confidence on scaling on the Unity Catalog? So right. So basically, Unity Catalog migration is not a single toggle button. It's more of an operational aspects. So you need to spend a lot of time in planning and designing how your data or how your access should look like once you move to Unity Catalog. So you have to define who is going to be the account owner, who is going to be the Metastore owner, who is going to be the catalog owner. So you have to define all those things. When you have these things defined, that you do in your planning phase. So first step is planning. So you do all this stuff, you define the roles. If you are in multi-cloud, then you, for example, if you're in Azure and if you're in multi-region, then you need to think of whether you have cross-region service endpoint enabled. If it is not enabled, then you have to enable it. So all those things comes into planning. Once you have those things planned, then you take one of the use case or one of the simplest workspace and try to migrate to Unity Catalog. Once you have done those POCs that everything works fine, then you try to automate it to move all the other things. And once you have all the things moved, then you decommission the old pipelines or your Hive Metastore. But you can still keep using Hive Metastore. There is no harm in it. But we say at some point of time, you have to let go the Hive Metastore. So this is what a high-level roadmap of migration looks like. We have a migration tool called UCX. UCX will kind of generate a report for you to understand what you need to migrate, and it can also automate some of the migration stuffs like group and users and workflows. So try UCX. UCX is quite new, and we are using it with a lot of customers. And meanwhile, when the migration is in process, you can still use the Hive Metastore and a sync command with Unity Catalog. So for example, you can use your old job to write in Hive Metastore, but use the Unity Catalog to read those new data that has been written, and use a sync command to keep all those data points in sync. Let me show you this thing. So quickly. Yeah, so basically the first step is, you have a Hive Metastore DBFS managed container or bucket. You want to use it to move it to Unity Catalog. You can use metadata clone and data clone for the managed one. And if it is an unmanaged or external location, you can use the copy command to copy the data into external locations or the new locations that is going to be governed by Unity, and then finally decommission the stuff. And I don't think I have time for demo, but one thing I want to highlight that this was hidden. So basically, this is where the Unity Catalog generally, add values to your generative AI or your AI model. So when I joined Thausbezog.nl, I was asked to create a matrix for gross transaction value, that is GTV. I was in a meeting and everyone was talking about GTV. I Googled for GTV and I found these values. So I don't know what GTV is. So let's imagine if you do any open source or any other SaaS-based model, SaaS-based LLM to use to find out what is GTV is, you will get these many values. But imagine if your Lakehouse IQ is built on top of Unity Catalog that governs your data, then you are going to get this exact value that you are looking for. So for example, Mac can represent Macintosh, Mac can represent media access control, Mac can represent monthly average customer. I'm sure if you search Mac in ChatGPT, you are most likely to get Macintosh and media access control. But if you have Lakehouse IQ and Unity Catalog enabled in your data, you might get monthly average customer. So if imagine that, how Unity Catalog can enhance the your AI framework or your model. And also you can use this kind of stuff. Like for example, if you do get revenue by SQ in Europe, so system doesn't know what is SQ and what is Europe. Your Europe can divide it into separate segments like Northern Europe, Southern Europe, right? So all these things can be easily done if you have Unity Catalog, and then you have everything, your own model built on top of your data, then you get kind of exact what you want. So this is what I would stop, and if you have any questions, you can ask me. Yeah.
Thank you very much, Kamal. Any questions? Yeah. Sorry.
Hey, thank you for the talk. About that software lifecycle architecture. I was looking at it and I was surprised that still you have multiple workspaces. And if you have like Unity Catalog, you have one workspace and you have a data plane. I was wondering, can you approach that with a single workspace, software lifecycle? And then an add-on question is like, in terms of volumes, will we see some kind of ML flow integration? Because I was always struggling with doing environments with ML flow within one workspace, let's say. You know.
Yeah, so I mean, generally for ML kind of stuff, it's better to have a separate workspace for ML environments. See, having different workspace doesn't segregate your data under the hood. It all in your S3 or your ADLS location, right? So if you have ML use cases and if you want to use volumes, you can still use same workspace, but our recommendation, keep ML stuff in a separate workspace. You can easily manage it. You can have different ML stages. For example, if you use ML flow and if you use model registry and all those things, you can see all those model transitioning from different stage to production and all those stuff, right? So ML flow is a kind of different, I would say, different arena of things. I would not, mingle around the same workspaces that is used for mainly your ETL pipelines or your data warehousing pipelines or all those stuff. So it's better to have separate workspace, but I don't think there is any issue if you still keep it in a separate workspace or in a single workspace.
I have a question. So at our company, we use Databricks, but we also use other Microsoft products like Azure, but also Power BI. So can we see in the lineage here also like Power BI or data flows in there? And in Microsoft, they have Microsoft Purview as well. So how do you think that they can fit together, or we use just one of them?
Yeah, so that's what I was talking about. So we now added the foreign catalogs to get the lineage from the ingestion side. Maybe in future we will add something for the output side, but as of now we don't have anything. So if your data goes outside Databricks and that is not part of any foreign catalog, we will not be able to show you the lineage, what is happening out there. But again, as you said, you use Purview. So I believe we have integration with Purview, or it is under development, maybe coming soon. Once you have that, you can leverage the Unity catalog lineage, put it into Purview, and then connect your Power BI also in Purview. Then you will have the entire lineage. So basically, it's kind of catalog of catalog. So we are not replacing any cataloging tool. We are kind of complementary to each of the cataloging tool, whether it is Colibra or Purview. So you can use Purview to basically get what is happening in Databricks.
But will we have then double cost because we use Microsoft Purview and then also Unity catalog?
Sorry?
Will we have double cost if we do so? Will we have double cost if we do so, like Microsoft Purview and then also Unity catalog?
No, so if you use Databricks, I'm assuming if you're using Databricks, you are anyways using Unity Catalog, not just for lineage, but for other purpose as well. So lineage generation there is nothing, it's a free of cost. So we don't charge anything for extra for lineage generation, right? So lineage is already sitting on those tables. You just get the data, put it into Purview and get the lineage, whole lineage. So there is no extra cost for getting the lineage out of Databricks to any other governance tool. Yeah. So lineage is already there in Databricks. Yeah.
Thanks for the presentation.
Yeah, thanks.
I was wondering if there is any possibility to add like data quality checks in the Unity catalog. So like range values or
exactly. So
like
that was part of the demo, but I think kind of. So basically, we are building called Lakehouse Monitoring, where you can see different kind of anomalies and all those things in the Databricks. So we kind of you kind of define the windows that you want to track, and then we say what kind of anomalies, mean, median, mode, difference, variance, and all those things. Those are inbuilt. Apart from that, if you using DLT, for example, I think Kivanch will more explain on DLT. DLT has inbuilt capabilities for data quality control and data quality checks. So if you are using DLT, you can have a separate kind of quarantine data set. Again, that can be governed by Unity Catalog. So basically, the DLT data quality and the Unity data quality will complement any of your use. But again, you are still free to use any data quality tool like Great Expectation, or if you are using DBT, you can use DBT test and all those things. But with Unity Catalog, maybe I can show you later, like we have something called Lakehouse Monitoring, which can track all those things. Yeah.
Any other question?
Thanks, Kamal, for the presentation. I have a question because it's more about the open source libraries, right? Pandas and Delta Rust APIs, etc. Would Unity Catalog also play well with those?
Like when you talk about those, like, can you give me an example, like what exactly that you are trying to do?
Yeah, so basically, if the data is governed with the Unity Catalog, right, what we observe is data scientists, they use a lot of pandas, for example, heavily, right? So then the data, you want the permission model to work with pandas, for example, or Delta Rust API.
Yeah.
But then the only fallback I see is delta sharing in that case or not.
So when you try to get the data out of Databricks, right? That's what you're trying to ask, right? Yeah, so when you try to get the data out of Databricks, I think for Rust we have native connector, but I don't think we have native connector for Pandas, but I think there are native connectors for Python. So Python SDK, you can use that. Or if it is completely separate environment, you can definitely use any tool which is kind of supports any REST API. So basically get the data as data share, and then you use it. But I think for Rust, we have native connectors. For Python, we have Python SDK. You can use that. Pandas, I'm not sure if there is any open source implementation of Pandas native connector. But if you use any other tools like in Trino or all those things, we have open source, we have native connectors for that. But yeah, you can definitely use delta sharing. There is no harm in using delta sharing, and it doesn't cost anything extra to use delta sharing.
Thank you very much. So, we're running out of time. Can we take it offline, please?
Yeah, you can ask me offline. Yeah.
Thank you very much,
Thanks.
Kamal. And now let's welcome Kivanch, who's going to talk to us about Delta Live tables.
Yeah, thank you. Nice. Okay. So first of all, thanks a lot for joining the session. I'm Kıvanç and I'm working as Senior Solutions Architect for Databricks. It's been like more than 2 years now. Today, I'm going to talk about how you can build modern data pipelines with Databricks. And let's start. So I think most of you are familiar with Medallion architecture, right? So you have plenty of data sources, you have bronze layer where you store your data, then you filter it, augment it, make some, data quality checks, and then you put your data into the gold layer where you do some kind of business level aggregates. And, this is really simple, right? But actually, the real life is much more complex. You have plenty of other data sources like Kafka, it can be Kinesis, it can be a relational database. You can, it can be a cloud storage. And you need to handle dependencies within different tables. You need to deal with the consumers of your table. And it's not that easy. And that's the real life. And as a professional, data professional, usually, let's really keep it simple. I received a message from my stakeholder asking that I want to see the churn. And what I only have is just JSON files stored in the cloud storage. And then I want to build a simple dashboard. Very simple scenario, right?
And as a Spark developer, I prefer Spark, let's say, I have 2 lines of code and I built something which is working. But then they like it and they want you to, for instance, run it every day, maybe every minute. Then things start to be challenging. So this is where you want to build, right? So you have some simple SQL statements and you want to make it production. But you need to think about the dependency management, the order of these tables, right? One of them should be finished and the other one should be start. But you cannot just recompute the whole thing, whole table every day and every day. So you need to think about partitioning strategy. You need to think about checkpointing. You just want to process data exactly once. You need to think about failures. And you need to think about data quality checks. You need to think about data governance, because you don't want everyone to access this data. And second one is, okay, you create this table, but how it will be accessible from other people? You know, other people needs to discover it. How you will gonna do that? And backfilling. Maybe you did something wrong and you need to reprocess the whole data. Or sometimes, you know, you just have some late arriving data, etc., and you just need to do backfilling. And how you will gonna do that? And version control. You will not be working alone, so you need to collaborate with others. So you need to have some kind of version control mechanism. You need to think about deployment infrastructure. For instance, if you are using Databricks, you are dealing with DBR, right? DBR upgrades even need some kind of testing. How you will gonna do that? Yeah, but you just needed to simply deploy these 2 lines of code. This is where we want to focus, right? I just want to tell what I want, instead of telling each time that I want, you know, this is how you can do, etc. This is where Delta Live Tables comes into the picture. So Delta Live Tables automatically handles dependency management between tables. It handles the expectations, data quality expectations for you, workflows for orchestration on top of that, repos functionality for version controlling, unit catalog with data governance. And now you could able to actually focus on the business value, not the other things. And DLT is a declarative way. It's not like an imperative way. When you take a look at the left side, you will gonna see that I'm trying to tell how it should do, how to do it, how to do that logic. But when you are using Delta Live Tables, you don't need to deal with lots of things. You just need to say what I want. I'm just saying I just need some sales based on date. This is what I want. Instead of saying, yeah, you need to read the table, then filter off based on this thing, and then get the sum sales, then overwrite the partition, etc. What we are trying to do is eliminate the boilerplate things that you need to do with regular Spark or regular things. So it automatically eliminates the boilerplate codes. It eliminates fault, it handles the fault tolerance. It automatically manages the state checkpoints, for instance, if you are using Kafka or cloud storage. It handles the object lifecycle, table creation and deletion, scheduling, dependencies, parallelism, optimizing. And the last thing is HMR, health mediated releases. What does it mean? So in Delta Live Tables, you are not specifying any DBR version. So in regular clusters that you are using, you need to choose this is DBR 11.3, this is DBR 12, etc. When you want to upgrade it, you need to test a lot. And DLT automatically handles it. You don't need to think about it. You don't need to think about any upgrades anymore. And let's say something happens, we automatically detect these bugs or problems under the hood. We don't even need to contact customers about it. Engineering automatically checks the problems. It understands that there's a bug in the DBR or something going wrong, fix it, and then your pipeline automatically continues, and you don't really feel everything's automatic, and your pipeline will not gonna fail at all. And there are 2 core abstractions of the DLT. One of them is the streaming tables, and the other one is materialized view. Streaming tables is pretty simple. When you are reading append on the streams, it can be like a Kafka, it can be like a cloud storage, it can be like a Kinesis. It's more like for the ingestion, and you can use it for low latency transformations at huge scale. And the other one is materialized view. It's mainly, it's really simple. It's the result of the query. And it materializes query, so your downstream applications can easily use it. For instance, like BI queries or Power BI reports, you just run a query and materialize it. But I will gonna go in much more detail into materialized view, but it has lots of good stuff like incremental updates. So when you take a look at the streaming table, as I mentioned, it just uses append on the data sources like Kafka, Kinesis, Autoloader, and it helps you to reduce the cost and the latency because it's, I will gonna talk about it, but you as a developer or data engineer, you want to process data incrementally, not each time creating the whole table or creating the same, reading the same input files, etc. So you need to build a logic, right? But with autoloader and streaming tables, it will be possible. And this supports update, deletes, and merge on the table. You can manipulate the data that you create as a streaming table. In this one, we are using cloud files as data source, which is like coming from the autoloader. And the other one is the result of the query materialized view. So you just define a query, it handles, it automatically materializes the results of the query into a view. But this is a bit different. This is again a delta table, like a streaming table. But you cannot change, you cannot run the ML operations on top of that. It's actually a view result of the query. If you want to change something, you can change the query itself. Data quality. So Stefan also mentioned that garbage in, garbage out, and we really want to make our data has a higher quality. And in order to do that, DLT has expectations. And the difference between great expectations, for instance, it's row-based. So it will base each row during the processing. What you just need to do is, for instance, you can just say, I want my, for instance, age greater than 0, price should be greater than 0. You can define this kind of expectations, and you have 3 options. You can just say, in some cases, maybe you just want to track, and it doesn't really harm your business. And the second one is, I'm processing millions of rows, and I don't want my pipeline to fail for just 5 rows. I just want to drop it. That's fine. And then you can choose, for instance, drop batch records. And sometimes it's really critical, because you are reporting to regulations, right? And in this kind of cases, you just want the job to fail. This is different than relational databases, right? In general, if they violate the expectations, then it fails, constraints. But in this case, you have these 3 options currently. And let's say you want to, very simple thing, you want to check the primary key constraint, and it's pretty basic. If it's more than it should be exactly 1, right? Primary key. And you can just say primary key and count star, and you can create something like this. And maybe you just want to validate for ranking constraints. It's again simple. If you are saying relational key is not null, and if it's null, you can drop them, or you can give an alert, or you can monitor it. And a very good thing. So, everyone, most of you thinks, Databricks is complex, right? And I think it's pretty simple if you just know SQL. Because now, for instance, DLT also is being supported with Databricks SQL. So even just knowing SQL, you can just create streaming tables or materialized views. You don't need to go to the notebook or etc. It's just, I can just create a query, then I can just schedule it, and Databricks will gonna handle everything automatically. And let's talk about streaming. Streaming is usually uses append-only streams. It really works well there. And data source can be like files uploaded to the cloud storage. It can be like Kafka, any streaming source that you have. And it can be delta tables, like change data feed through, and you can just read it. You can read the transaction logs. It's really good. And rather than waiting all of the data is arrived, you can just also schedule it to process data incrementally. It provides lower latency and lower costs. And people are thinking streaming is expensive, right? But the power of streaming comes from it processes the data incrementally. So you don't want to process data, whole data again and again, and for that reason, you usually tend to build something like, if I already processed data, I don't want to process this data again in the cloud storage. You build your Lambda functions, etc. There are 3 different ways, to process data incrementally. So you can just run it manually, which costs lowest thing, but in terms of business values, it's not good, and latency is highest. You can just schedule it. In the same way, it will gonna process data incrementally from 10 minutes to months, and you can just process it as a stream. In this case, it's a bit more expensive for sure because it needs to be up and running, and the latency is low. When you choose continuous, it will gonna run everything continuously. And this one is quite important. I just want to talk about this listing and notifications. Let's say you have 10 millions of files in the cloud storage. Even listing is really difficult, right? You need to find a way. And with the autoloader, we automatically connect it to notification apps in the cloud providers. And when there's a new file, we automatically get the new files and then process them. And schema inference and schema evolution is part of the streaming tables. It's pretty easy, and it's pretty easy to use. You just need to say, instead of create table, you just need to say create streaming table. And there are different things, by the way. You can just say read files, or you can also say read Kafka if you are using SQL. And in this case, for instance, this is the Python syntax. When you want to read Kafka sources, you can just say, it can, by the way, event up, and you can just use the same Kafka or event up connector. I will gonna have a demo on the IoT app. But you can just specify what you want to read Kafka. These are the configurations, and you can just subscribe to a topic. I want to mention one thing here. DLT has the best auto-scaling in the Databricks environment. So based on how much data that's in the Kafka topic, it can automatically scale up and down based on the data that you have. And I'm going to explain, but with the DLT service, it's even much more better. And yes, in Databricks SQL, there's a support as well. You just need to say stream on the table, or stream on the cloud storage. Then you will also able to use streaming in Databricks SQL. Change data capture. So let's say you have some data CDC files coming from your relational data store, relational database, and it provides you some kind of CDC data, which just says updates, deletes, and inserts. In order to handle that, we have apply changes syntax. And it's pretty simple. What you just need, a target, right? I want to make these apply changes, which means like an upsert. And I want a source, which is like a streaming source. And then I need to provide a key. This should be unique. And then you sequence by timestamp. It can be like, upload timestamp, or log sequence number, or ingestion time, and this kind of things. And Delta Live table will gonna automatically handle out of order rows. So let's say in the same batch, you have 3 rows, but you want to keep the latest. And Delta Live tables can able to do that. And let's say, as an example, I have something like timestamp 100, which is Beckerly. And then I have an update for that one, which is Berkeley CA, which is the right one. With apply changes it will gonna automatically update it. This is more like a CD type 1 scenario. And you can have these things from, change data capture from different relational databases. You can just put them into a cloud storage or Kafka or Kinesis. We can get them and apply them into Delta Live tables pipeline. But we have some good news as well. So federated CDC with Unity Catalog. In this case, we introduced Lakehouse Federation. And what we will gonna try to do here is, instead of you are dealing with this Debezium, getting the change data capture, etc., you can connect to these databases. And then what we want to do is get table changes from these databases and tables, And then you don't need to configure lots of stuff. We will gonna able to get CDC for you. And other part is SCD type 2. Sometimes you want to keep the history instead of just updating it, because maybe it has a different label previously and it has a new label now, and you want to track all of this history for your rows. And in this case, what you just need to do is saying stored as SCD type 2. Then it will gonna automatically track the history for it, and it will gonna add 2 rows, 2 columns, start Z and end Z. Even if you have 3 rows coming from the same batch, it will gonna able to do that. And in this case, in the previous situation, you remember it was just updating this one, but now it says that it starts at 1 and ends at 2. 2 is here. And this is the new value. So you don't lose this value anymore. So you can keep the history of these rows. And materialized views is the next one. Materialized views, really powerful thing. The reason is you create this bronze silver, but you want incremental aggregation on top of your data. And it's not that easy to do it in streaming. It doesn't support it. So what you just can do is use materialized view. And I'm going to explain, but materialized views uses enzyme under the hood. And it will going to handle updates, deletes, or appends into the inputs. It supports any aggregations or window functions, but some of the functionality is not there with the enzyme. We have a roadmap around it. It just works with the ad hoc queries. You just have a SQL which is running fine. You can just create the views there. And I want to talk about enzyme. And in the enzyme, let's say you have a new row. Normally, you just need to recompute everything. And what you just need to do with the create materialized view is, just at the latest one, the changes only. In order to do that, you have 3 different options, right? If it's like a monotonic query, which is more like an append only, and when you have a row here, which is added, it just appends, blind appends. So it's very fast. It only works with, select, project, and inner joins, but it doesn't handle changes in the input. So if you have, for instance, in a streaming application as well, if you have updates, deletes in your streaming source, you are going to have an error. And you can say ignore updates true, etc., but then, that's a different story. And the second one is partitioning computation. You know that which partition is being changed. And in this case, you just need to recompute the latest partition instead of recalculating all. But in this case, the input and the output should have the same partitioning. And the third one is merge. It's coming from the data warehouse technologies, where you just want to update the thing, what's being changed here. And here, for instance, it was like there is a difference here, and we just need to update this row with plus 17, which is more like merge, but it's really expensive. And, it can handle updates, insert lists into your source. But, yeah, it's difficult. But we are really working on this one to make it really efficient. We have lots of professors working on it. And what we are trying to do with the enzyme is based on your, we build it on top of Catalyst Query Optimizer. We are looking at the transaction logs. We are trying to understand the cost model. What will be the cost if I run it monitoring append, partitioning compute, or merge updates, and choose the optimal update technique on top of that. And I want to introduce the DLT service as well, which is in private preview right now. Enzyme is only available with DLT serverless and materialized view. There's 2 ways to achieve it, to use it. And when you use enzyme, it will gonna work with co-partition, associative aggregates, and monolithic queries right now. And we have a roadmap around in-router joins, semi-ring aggregates, distinct aggregates, window functions, and predicates on the current date. If you want to put all things together, let's say you have some cloud files, source systems like Kafka, Kinesis, or some cloud storage. You usually store these files with a more short retention. So Kafka, for instance, you have a duration, right? So you're not going to store it, for instance, more than 7 days or something, depending on what you want. And then what we usually do is we are putting this data as raw as possible into bronze layer. And we avoid usually complex transformation. The reason is, let's say you made complex transformations here, but you did something wrong, but then you will gonna lose the raw data. In order to make it work, we just load this data into the bronze. You can just retain it with infinite history, and then create materialized view on top of that for instance, cleaning. You can just run something, queries on top of that, and you can serve it to the BI applications. I want to explain this one as well because this is really powerful. And what you can do is, let's say you are moving from relational databases or SAP where you have thousands of tables. And let's say you have a source system and they have the same dynamics, right? And with the metadata-driven approach, you can just have, for instance, YAML file, or maybe it can be like a Delta table that you store the configuration. And you can create like 1,000 tables into one, into different pipelines for sure, but hundreds of tables into single pipeline. In this one, for instance, for each region, I want to create a table. And if I just create this function, for each region, it will gonna create a Delta Live table into the pipeline. This is really a powerful one. So let me check how much time I have. Yeah, I have some. So let's go to demo. So we talked a lot here. Okay, I think I can make it bigger. So first of all, I want to show this part. So let's say I'm just a SQL user. And by the way, this is the serverless one. And I have some JSON files stored in the cloud storage. What you can do is just saying read files, and then we will gonna wait a bit because this will be up and running in seconds. You will able to read the files. You can just process it incrementally. As you see, it's up and running. You don't need to wait like minutes or something. You can just run the query. Now I can see the data itself. Let's say here. So I have some sensor data coming. And I can just refresh a streaming table here. Let's say I have an IoT data coming from my turbines, and I want to do more like a predictive maintenance on top of the data. So what you can do is you can just create a streaming table, you can do some kind of analysis, and at the end maybe you may need to create some features which can be linked to which can be an input into your machine learning feature store, or it can be like it can be more like a report on top of that. And then when you run it, this one is pretty simple. You will able to see the data coming from this materialized view. This one is pretty simple, and if I want to productionize it, I can just go to workflows. This is just, I'm a SQL user, right? I just say, instead of create table, I just say create streaming table. I just told, create materialized view, that's it. And then what I will gonna do is, if you go to workflows, you can just, for instance, create a job, and I can just choose SQL, and then I can just provide the query. For instance, DLT demo something. So then, let's say this one, and then you can choose the warehouse, and then when you just create it, you can just schedule it or create your task. It's pretty easy. So a few steps. Create streaming table, create materialized view, just create the workflow which uses this query, that's it. And the second one, I want to show another demo for manufacturing. So let's say I want to understand, I don't want to go through the code, it's more like boring stuff, but I want to just understand overall equipment efficiency. So how efficient my equipments or machines in my factory. And in order to do that, you need to understand the availability, performance, and the quality. And the OE score is the combination of these things. So what we're gonna do is I have a simulator, Raspberry Pi, which we're gonna send data into our IoT app. Then we were gonna put this data into Bronze, and then we were gonna clean it, and we were gonna combine it with some batch data, which is more like shift data coming from SAP or Salesforce, and then I will gonna combine them together. So doing it is pretty simple. In the workflows tab, you are gonna see Delta Live tables here. And this is, you just need to say create pipeline and put these values, but I will gonna show it in pre-built something. Currently, it's still up and running. So what you just need to do is go to settings. You just need to provide the name. You can choose if it's serverless or not. You can choose the product version. It has 3 versions. And you can run it as triggered or continuous. In my case, for the sake of demo, I'm going to run it continuous so we can track, the files arriving and then processing. And you just need to define the storage location. Currently, I'm going to use DLT with UC. And I'm going to have a target schema, which is like OS core demo. So let's move it from here. So in order to simulate situation, I have a Raspberry Pi simulator, which we're going to send some data around meteorology, like, it can be like temperature, disk space, etc., on how much it produced, how much of them are defective. And as you see, it just sends data here. It's quite fast, so maybe it's not easy to see right now. But what we were going to do with this thing is you were going to see that it's continuously processing the data. These numbers will going to increase. For instance, when I click in one of them, I can see the data quality of them, how many of them are written, how many of them are dropped, but for which reason? You can see all of these details. Let's say the gold one, as you see, there is a warning with low temperature, and there is an issue with this one, and there are lots of failed rows there. And then you can, for instance, see the view logs, which gives lots of information about what is happening there, how many rows processed, how many of them has data quality issues, even the data lineage. And you can combine it with monitoring, by the way. And you can see the schema, or you can just schedule it with the workflow over here. And there are 2 different ways. One of them is running as development. You are developing something, but at the same time, you can just run it as production. In development mode, it will gonna keep the clusters up and running for 2 hours, and it doesn't have retry policy. It will gonna just fail, but production will gonna handle transient errors, what's understood. So let's say it's running now. I can just build a dashboard around it, which is pretty simple. Currently, I process like 75,000. Oh, it just increased a lot. So it's now 140K. You can just see, how many total sparse made, the summary for the plans. You can see the OE trends, or you can just track, temporary disk usage, etc. And the other thing is, 10 minutes, okay. So the other thing is, we discussed, let's update this one again, so we can see that we are processing some data. It's now 140K. So what we did is, just use a simple IoT simulator. It can be your event hub, it can be a Kafka, it can be like a cloud storage, but for the sake of demo, I'm using it with this simulator. So we are getting data, we are processing it, getting some data from bronze, silver, and gold, and then just show it in a dashboard. That's good, but what else? So I want to show you this one. So you can just build a dashboard, because event logs table is just a system table as well. You can just see how many rows that you process daily, how many of them has data quality issues. Per layer, you can have all of this information and just combine it into a dashboard. And the second thing is, everything that's created by DLT is stored in Delta tables, right? So in this one, I created my data under, this is my catalog. This is my schema. This is where I stored my data. And then let's say I created some of the tables here. I'm going to click on one of them. As you're going to see, you can see the sample data, etc. This is more like the simple stuff. But I want to show you one thing. You can just go to lineage. And let's say I have this gold table, which is created by using these two tables. This is what you know, right? And this is what you also see in here. So I have gold table, which is a combination of silver and work for silver, and I have a bronze table. You will gonna have this information as part of Unity catalog. So you can see, for instance, gold is created by using the silver, and you can just click here, okay, silver is created by using bronze. And I want to know that shift number, where it's coming from. You can see that. You can see where the plant name is coming from, which column. You can see all of this information. Or when I click on it, I can easily say that this one is coming from this field, this coming from this field as well. And the last thing is, when you take a look at the quality, I think I have it in the silver layer. But you can also build lakehouse monitoring on top of this data, where this is the silver table. For instance, you can see the insights. By the way, in the lineage, it's not just table, but you can see the notebooks, workflows, pipelines, and dashboards as well. You can see the insights, what kind of query it's running, frequent notebooks, frequent join tables, etc. And in the data quality, for instance, you can just enable lakehouse monitoring on top of data. And based on it, when you click on it, it will gonna show you a dashboard about, for instance, some data quality metrics on top of the data. For instance, this is my table. You will gonna see the number of row counts. I need to update it for sure because it was fresh. But number of zero values, number of nulls. You can do time slicing, data integrity checks, etc. So in general, I just wanted to introduce, modern data pipelines with Delta-like tables. I'm happy now to answer the questions. Thank you.
Any question? Yeah.
Yes, thank you. In the past, I used structured streaming, which the Python API is already sort of a layer on the Scala streaming engine. And once you start running it, it just goes sort of a little bit like a black box and keeps running forever. And now there's this extra layer of DLT, which abstracts away the nuts and the bolts. What I sort of miss until now is like, how do you debug that, and what is the development experience of a DLT streaming table? If structured streaming was already quite challenging to debug, and we're talking now about an extra layer on top.
Yeah. So, for instance, let's say this is built on top of structured streaming, right? And then everything that you can use as source for structured streaming, you can use it. I mean, for DBR, if it supports, you can read it. It just creates a layer, but it also tries to solve some of the challenges that you have with structured streaming. What is it? For instance, it cannot handle updates, deletes, these kind of things. So we have enzyme for this one, which really tries to optimize it. It automatically tries to increase the batch size, pipelining it, etc. For instance, auto-scaling kind of things. So you can just think about, okay, another layer, but which tries to fix lots of issues that you have with the structured streaming. So you don't need to think about, watermarking there, stream-to-stream joins, etc. I mean, you need to create this watermarking states, etc. For materialized view, as you see, you don't need to define anything, even if it's stream or not.
Yeah, but for instance, a crash on the schema change.
Schema change is automatically handled with DLT. So it will gonna handle automatically.
Let's say you don't want to accept the schema change, right?
Depends.
Yeah.
Yeah.
But it's presented as if there's no crashes, no debugging involved.
You can choose to crash or add them as a rescued column, and then you can just, there is a schema evolution thing. And when there's a schema change, for instance, then what you don't expect, let's say. And then in this kind of situations, it will gonna add a column. It's already a rescue column, and you can analyze. But sometimes also it happens in the source system, right? Maybe they are sending millions of files with correct schema, but there's a new one which has some data code, schema problems. And in this kind of in this kind of situations, it will gonna store it in the rescue data column, so you can analyze them. You can build a path around it. You can filter them, or you can just abort it. You can also even define constraints like I do here.
Any more questions?
Thanks for the demo. I was wondering if you might have a similar kind of demo, but not from the UI, but from code, either using something like DBX or Terraform.
Okay, but you can create DLT pipelines with Terraform, but it just creates the DLT pipeline itself, right? So the code itself, a notebook or something, is different. From the automation side of things, you can use whatever you want. You can use Python SDK or Terraform, but it's more like deploying the DLT pipelines. It's not just, you still need to code, in a notebook or something, or your environment. But Terraform, I don't have a demo for that one, but it's pretty, we have plenty of documentation how to create DLT pipelines. And I highly recommend also, besides Terraform, we have Python SDK, which is really powerful, and Databricks asset bundles, really powerful. You can use that one as well.
Thank you.
You're welcome.
Does anyone else have a question?
Okay.
Yeah, I kind of have the same question as the other question before, because we also used the product last year, and we tried it out for 6 weeks, and like with all the demos and all the small data, like 50 megabytes, 100 megabytes, it works all nice. But once you start with still even small data, but say like 5 terabytes of data, we just only wanted to load our data into the system. It was structured already. And like I set up a ClickHouse server, it was like an hour to set it up, took 6 hours to load the data. With the Delta Live tables, it took a year and a half if we would have kept it running. And for 6 weeks we were like with your colleagues and everything, tried to get it to run the different solutions, but it's just really, really slow once you scale the data up. And so we also had the same problem, like because everything is abstracted away, like how do you debug it? Because there was like, okay, what do? We tried like all the different settings, but the problem is because it's like abstracted away, everything, there's also little documentation on actually what's going on. Like if you use the open source Spark solution, there's really good documentation about that, but with the Databricks solution, it was like, okay, go year, and then like, well, if we talk to employees of Databricks, they will give me a link and they say, okay, yeah, here it is, and then like you're one step further. But like, how do you solve that? Because basically, I became too frustrated with it and was just like, okay, we're not going to use the product at all because. Yeah, it's taking too much of my time to just every time email with the customer support. And so the debugging was the problem for me as well. And then we were just like, okay, let's just use a simple solution where we can just get averages and variances, because then at least we have something to work with instead of trying to debug something which is like, oh, it has a really high abstraction layer.
Yeah. In terms of, debugging kind of things, what you can do is you can make things more modularized, right? So what I mean is you can just create your Python, in the software engine, what we are doing is, create these functions and call these functions. And DLT is just on abstraction on top of that, right? So you can build your functions, test your unit testing or acceptance testings for debugging, and just put this function and call this function in the DLT, because anything that returns data frame will gonna work in terms of coding. This is. And the other thing is, in terms of scalability, we really need to go through case by case. But we have customers like, for instance, processing trillions of rows or billions of rows, that's fine. But we just need to understand where it's coming from. For instance, we don't want you to deal with, worker types. DBR is safe, but you can, for instance, change the instance types. You can change the auto-scaling features. Because it's an abstraction, but anything that works with this one, even this one should be much more optimized, by the way. But we really need to go deep dive on what's happening there. There should not be that difference. This is what I see in my practical experience. But if there is something happening wrong, the good part is, we have lots of product teams who can actually support you in that one.
We just had an S3 bucket
with
CSV files,
which
all have the same structure.
Okay, but
so, I mean,
the difference is,
but
the difference is, for instance, possibly you are using autoloader, right?
I think we tried like all different solutions. We also used the Delta live streaming tables, where we just basically put it on a new folder, then just started like transferring the files into it, so it automatically loaded it into the tables. It's a year ago. I don't know exactly. We tried I think you have 4 or 5 different solutions, I believe, in way of loading it, and it was just always slow. And then of course you got the auto scaling, and you can add more compute power to it. But if it's in the ingestion part, especially, we really need to think about, you can try different things, but if there's a file in the clusters, the best way is using autoloader. And autoloader has many options. And mainly, when you have this kind of huge amount of data, you can choose a different way to load the data, like the notification apps, etc., instead of directory listing, because it's more like the API calls that you are making. And maybe we really need to take a look in more detail, because small file issue, for each file you are calling the API calls. And if it's happening in the ingestion part, it can be related to this thing. But I cannot just generally say something, but I can say that it will gonna work. Okay, we're just files of 4
gigabytes,
but I think that's maybe then just a solution. Maybe it's improved the documentation on doing all these things about the loading.
Yeah.
Because when I tested it out, like I said, the product is amazing once it's everything in there, but we just ended up dropping it. And when I talked to a lot of other people, they also had this same issue where they were like, well, okay, just getting up and running was too hard, so we dropped it.
Yeah.
But whenever we had something data in there, it's a beautiful product and you can do a lot of things with it. But it's the debugging and the lack of documentation about what to do when it doesn't work, like the demos.
Yeah, it's updated a lot. The documentation, the cookbooks, how you can read, etc. I mean, in 1 year, there is a huge difference in both of them. And I haven't talked about liquid clustering and this kind of things, for instance. And it will gonna give you 2 and 4 times better performance, and it will be supported soon. And this kind of things. But it's a bit more different than what you see 1 year ago, something.
Thank you very much, Vansh.
Yeah, you're welcome. Sorry.
And now I'm happy to introduce my colleague from Xebia Data, Daniel, who's going to talk to us about data testing.
Perfect. Good to go? All right, so hello, everyone. Great to see you all here. And I'm in between you and lunch, so I hope you can keep your attention with me for my talk, because I understand if you're hungry. So today, we're going to return to Data's Inferno to see if the 7 layers of data testing hell are still relevant. So before we do that, just quickly, who am I? Hello, I'm Daniel. I'm a data engineer here at Xebia Data. What I like is things like automation, robust data pipelines. I also like memes. You might see them in my slides, sorry. What I don't like, bad data, manual processes, and stuff that's in Excel sheets. It just makes me antsy. I don't feel comfortable. So before we get going, who here has heard of Data's Inferno? Ooh, nobody. That's great. So it means, oh, one person here? Okay, cool. So perfect. You came prepared. I like it. So then we have many uninitiated people here. That's awesome. So Data's Inferno was this idea we had back in 2017 or 2018. And it was a meetup talk, a conference talk, a blog post, and a GitHub repo with the code showing what we were actually doing. And really, Data's Inferno was about data quality. And we get this sort of cliche idea of, well, garbage in means garbage out. But it's true. And the background for Data's Inferno was we were really suffering with this problem. Not even so much from a data science model perspective, but also really from a does this data make any sense kind of perspective. We were having issues back at ING. This was built with dealing with private individuals. For GDPR purposes, we would need to identify like who's a private individual and who isn't, and that actually turned out to be really hard because the data sources were all different and they interpreted things differently, and harmonizing that was just really, really difficult. I'm losing my microphone slightly. So for me, this talk is a trip down memory lane, and as any programmer knows, a trip down memory lane goes like this. At least it does for me. I'm like, oh my God, I wrote this code. How was I crazy? Was I drunk? Was I both? This is horrible. First stop is to look at the environment we were working in at the time. So back in 2017, 2018, this was at a high level our stack. So you can see tools there like Apache Spark, Postgres, Python, Druid, Scala, and Hadoop. This was all on-prem at ING. And I think if you look at this environment, most of these tools have sort of stood the test of time, at least up to a point. Apart from this little yellow elephant there, I think most people here are no longer working on Hadoop, or if they are, it's probably on a pathway to no longer be there. And the important thing to realize here is that this was one environment. So we had one Airflow, we had one Hadoop cluster, and we were processing billions of transactions and running a production app on top of this. So that's where we came up with this, which was Data's Inferno. And Data's Inferno was a way for us to sort of get back in control of what we were actually showing to our end users, who are risk managers, business analysts, people in the bank talking to customers. So they needed to know that the data that they were using for that communication actually was correct. That that they could say, hey, this is what we're seeing and this is the truth. So it was a layered approach. The layers are up there on the slide, so I'm not going to read them all out. And so for this talk, what we're going to do is 5-6 years later, take a look at each layer and see, well, has this layer stood the test of time? Are we still going to be doing this in 2023? So it's good that we're going to do this in a way to also bring everybody up to speed quickly, considering most people here haven't heard of Data's Inferno. We're going to do each layer, and I'll quickly explain what it involves, what it means, and then say, is it still relevant in 2023? So our first layer is DAG integrity tests. So for anybody that has ever written an Airflow DAG before, this probably looks quite familiar, right? You have a task, and another task, and then a third task, and there are bash operators, and you're just typing along and doing your thing, and then you say, okay, right, great, I'm ready to run my DAG, to see what it looks like, to see that pretty graph, or look at the grid view, or whatever. And then this happens, and you're like, what? Cycle detected? What's happening here? And of course, we're developers, and we're lazy, so we copy-paste. And what happens when you copy-paste is you forget to do some things. So in this case, I remember to rename the variable, so I made the variable task B, mostly because my editor complained about it, but I forgot to rename the task ID, and the task ID is actually relevant for Airflow. It's something so simple, but in the end it cost us so much time just figuring this stuff out. So what we did is say, well, what about if we just test this in advance before we even deploy to Airflow? Just check, simple check, is this DAG even valid? And so to do that, this is the pseudocode, so it won't work out of the box, but the code is available at that link at the bottom of the slide. Which we load all of the objects that we can find in all of the Python files that we think are DAGs. We check, are there even any DAG objects in there? If there aren't, that means that we've forgotten a parameter or something else is wrong in the DAG definition. And then we check, are there any cycles here? And it seems so blindingly obvious, but this really can save you a lot of time. Yeah, so again, full code available. Also, any of the other examples, and also the examples back from 2017 and 2018 are also in that repo, if you want to see what the code looked like back in the day. So is this layer still relevant in 2023? Yeah, I think so. It's a really simple, lightweight test. You can just run it. We used to run it in our CI/CD pipeline before we deploy. It can save you time. It doesn't weigh you down much. The second layer was this idea of splitting data ingestion from data deployment. So what we had was we had a web application that had a backend database, Postgres in our case, and Druid. And what we would do is we need to crunch all of this data in some way in Airflow DAGs on Hadoop, and then load this data into the backend of the app. And initially we just said, okay, great, we have 4 data sources on this slide. Let's just load the data and then deploy to the app in one big DAG. That caused us a lot of headaches, because what would happen is these data sources would change, the data transfer would fail, some other weird edge case thing would happen, and then that single data source would block the deployment of the entire app. And that just really causes all sorts of issues and complaints from users because the data wasn't up to date. So what we did then is we said, well, as we separate out every ingestion pipeline into a separate DAG, a separate pipeline, that sort of containerizes or maybe abstracts away that data source. So if that data source fails, the DAG for the app can still run. It can still deploy to the app, but one data source is slightly out of date. So in a sense, we then, well, I shouldn't say in a sense, I should say that actually led us to defining interfaces. And the interface was uniform because we were dealing with a large bank that was a merger and acquisition of 20 years and all sorts of weird systems joining together, but they should be representing the same thing, a payment transaction. Money goes from A to B. It shouldn't be that hard. It turns out it is. And having that single interface also conceptually made our life a lot easier. It made it easier for us to just talk among each other as a team developing this stuff, like, hey, this is what a transaction looks like. So it's more of a procedural layer, more of a sort of a process, high-level design. So still relevant? Yes. It just decouples your setup. It makes it a lot easier to work with your pipelines, especially if you have multiple data sources representing the same thing in a different way. So we're layer 3. Layer 3 was data tests. And this essentially boiled down to after every task in your Airflow DAG in which you are doing some transformation, you have a test task. We were quite stringent in this at a certain point. We would do a test even after something as simple as a union. So you have 2 tables and you union them together. That should just always be exactly the same. We had cases where that caused trouble. So we just went full, real strict, test after every task. And it saved us a lot of problems further downstream. And nowadays, you could argue, well, do you really need to do this, a testing of a union? I don't know. It will depend a bit on your environment. It's a trade-off, right? Because the tests also take time and therefore money and resources to actually run, so it needs to be balanced slightly. In terms of implementation, what this looked like back in 2017 was something like this. We had our Spark job, and it was essentially just a SQL query. So in this case, we were doing a double left join. And what we're trying to do is bring in country information or information about the participants in a payment transaction. And you can see the SQL itself isn't super complex, but we have to wrap it around in this spark.sql and do something with the format, and then we'd be good to go. Our test task would then look something like this. Again, a Spark SQL query, and then some Spark things to make it work so we could actually do the assertion. So just to explain the test quickly, we were checking if any of the records in our table now are still missing a country. They shouldn't be missing that information anymore after this task. In 2023, there's this tool called DBT. It's quite popular nowadays. And in our case, what it would do is it would just abstract away all of this Spark stuff. You don't no longer have to think about Spark.sql and first and count and whatever. It's just SQL. And the SQL hasn't changed. It's the same query that would run, and the same actually holds for the test. The test is the same. Slightly different syntax, but if you read through the query, you'll see it's still counting nulls. It's still validating that these country fields have been filled. So is it still relevant in 2023, this idea of data testing? Yes. The tooling has changed, right? We no longer need to do all this Spark and Spark submit. You have DBT, which handles most of the Spark stuff for you, but the idea is still relevant. Number 4 in our journey into the layers of data testing hell was alerting. So with alerting, it's again, some of these things seem so simple, but they solve so many issues. What we had initially was people logging into Airflow every hour or so to see whether the DAG had failed. And that just was really painful. So we integrated Slack with our Airflow DAG, and anytime something would go wrong, you would see a message from Chuck Norris, and Chuck Norris would tell you, oh, a failure, this task failed, check the logs here, et cetera, et cetera. It wasn't just triggering us to show like, hey, this thing is failed. It actually changed the team dynamics. Can you see some people mentioning each other or replying to comments here? That was actually saying, hey, your thing failed, or check in here. Or in the case of a comment, like, yeah, this was me, I'm sorry, I screwed something up. And that actually really helped in transparency. We were quite a big team, and being able to understand like what another person was doing and what impact that was actually having was quite helpful. Back in 2017, we built this ourselves. I sort of condensed this slightly because it was quite dense initially, because we had to go through corporate proxies and all sorts of other things that we had to figure out. But it worked, but we had to build this ourselves. We had to home build it. Nowadays, 2023, there's a provider. Its interface is actually pretty much the same as what we had defined. You just say what the text is, where you're going, and you're happy. You get notifications. Still relevant. Well, yeah, I'm not sure if I should reply with a meme anymore. Just say yes, we're still good. We're still looking okay. Again, implementation has changed. Underlying idea is still there. Layer number 5. So this was Git enforcing, or as we like to call it, nuclear Git. So what nuclear Git did was sort of enforce process on a very weird environment. So again, we had one Airflow instance, one Hadoop cluster. So bringing stuff into Airflow to actually run was tricky. You would need to commit it into Git, and then it would roll out. But then obviously you'd figure out, oh crap, I've screwed something up, I made a typo, I forgot something else. So our data scientists, but also our engineers, would actually log into the Airflow host and then play around a little bit while debugging to understand what the problem was. And the idea was that from there they would check it into Git, and then everybody would be happy. But as you all know, you forget things. You forget to check something into Git, and that led to 2 big problems. So one, people would leave stuff not checked into Git, running in the Airflow environment, and then the nightly batch would start to run, and it would fail because somebody was mid-debugging session and had broken something and forgotten to revert back to the original branch. So it impacted our real environments. And then the second thing was also, it's just not very nice to leave stuff not checked in. So to solve the first one, we introduced this idea of nuclear Git, which essentially at midnight would just do a hard reset of whatever was there and just bring it back to the main branch. And it would obliterate anything that was there that people had checked out locally. This did lead to some cursing in some corners on some mornings when they came in and realized, hey, where's all my work from yesterday? Where'd it go? Queuing, well, explanation, and then slowly but surely you started to see that people actually would start to always check in their code. So it was saving our production environment, but also encouraging people in a sort of a harsh manner to actually bring their code into Git. So the question for this one is it still relevant in 2023? And I think this one is a no. This really was a quirk, a weird sort of artifact of our environment that we had to introduce to make it workable. If you still need to do this in 2023, I think you have bigger problems you might want to solve than doing it like this. The underlying message, of course, is make sure that you're in control of what's running in your production environment. That's still valid, but I think there's too much in here to say it's still valid. So layer number 6 is the idea of mock pipeline tests. And before I go into what they actually mean, it's good to sort of take a look at why are we introducing these. So Data's Inferno, in a way, is a sort of an interpretation of the Swiss cheese model, right? With the idea being is there, in every slice of cheese, there are always going to be holes. But if you stack enough slices on top of each other, in the end, you're probably going to cover most, if not all, of the holes. In our case, the slices of cheese are our tests. So we had unit tests, obviously, to test our code. Then we had data tests on the other side to actually test the live data. But we're still missing something in between. Like, okay, but there's quite a big gap between those two things. So we said, well, let's bring in mock pipeline tests. So run the entire pipeline through and mock the data, and then make sure that along the way you could plug in, like, is the data still there, is the data still there? So it's almost like an integration test in a sense, full pipeline test, checking, are we still there? Is it still okay? Does this make sense? So back in 2017, it looked something like this. So we would have some data that we would generate, in this case, Donald Duck from Duckburg with a certain IBAN. We would run our pipeline, that's filter data or something and whatever. And then at the end, we would say, well, Donald Duck wasn't allowed to pay money for some reason. Maybe he was bankrupt or whatever. And it's just a simple query like, is it correct that that person is gone, that that account is no longer there? In 2023, hey, there's that the DBT thing again. We still have our synthetic data, which we would generate. But now we can use DBT test. And actually just say, well, there's a certain type of test that I want to run now, the mock pipeline test, and run those against this test data. And then again, we would run our test query to see, are those things now actually gone? This saved us hugely once we started to introduce this. It was a real pain to implement because you had to actually think about, okay, what kind of data do I need to generate? That's the hard part. But once we had that in place, the number of times we were saved by this, because we were dealing with so many systems and so much complexity, it was really hard to think everything through before it would hit the actual Airflow DAG running in production. So is this still relevant in 2023? Yes, definitely. Especially now with DBT. So previously we would actually have a separate test base for the mock pipeline versus data tests and versus unit tests. But now with DBT, you sort of harmonize that into one. So you could even run your data tests in your mock pipeline environment, in your integration test environment. And that really adds an extra layer. It just would be, in hindsight, I think, if only we would have had DBT at the time, life would have been better. But that's always a great thing about hindsight. And finally, layer 7. So we've stacked these layers not necessarily in the order in which you should implement them, but more in the layer in terms of complexity. So layer 1 was relatively simple. Layer 7 is tricky. So layer 7, what we said is on top of all of these tests that we do and checks and whatever, we are also going to designate separate environments, and every environment had its own purpose. So at the time at ING, we said we have 4 environments: dev, test, acceptance, production, which If you're in any sort of application development, if you have that kind of experience, then they sound familiar. And each one of them had a very specific purpose. So in dev, it was really just, does this thing even run at all? And we don't care whether the data makes any sense, just percentage sampling, does it even work? Can we even run the queries? Test, we had a very hand-picked set of records or groups of records that we would push through to make sure, like, do the relationships actually add up? Does the app make sort of sense for a specific subset of the data? Acceptance was a full carbon copy of the data. So if we had 7 billion transactions in production, which we did, acceptance would have the exact same. And we did this, it was quite sort of heavy-handed in a sense. It was a lot of data to duplicate, but because the data quality of the source systems was so low, we had to get an environment in which we had the full quirkiness available, basically, of all the data. And then production, obviously, was production. So back in 2017, how this worked was, well, we only had one Airflow environment. So these environments, in a sense, they were separated. We had DTAP, but the orchestrator running the DTAP was still just this single point of failure. And that was something we couldn't really get around. So what would happen is you would have your DAG checked out 4 times in dev mode, in test mode, in acceptance mode, and production mode. And every time, once one of them succeeded, it would automatically trigger the next one. So first dev would run, then test would run, then acceptance would run. And then between acceptance and production, we had a manual approval step. So we would ask like a product owner or somebody with some business knowledge to log into the acceptance environment, the app, and say, is this okay? Does this make any sense? Is your problem now solved? And it helped a lot. Especially we were integrating a couple of machine learning models into these pipelines as well. And those integrations usually initially would fail on the development side. And because the development side data was so small, I think it was 0.0025%, it was really quick to fail. It would be sort of minutes rather than hours. In 2023, if you wanted to implement this same split, the same number of environments, I think I would go with something more like this. So actually split out the Airflow instances into 4, and then between the environments, I would use Git or some sort of CI/CD trigger to actually make sure that the next one would start running. This also makes it a lot easier to do Airflow upgrades. At the time, an Airflow upgrade for us was like a terrifying thing, because you would do an Airflow upgrade and then stuff would break halfway, your database would be corrupted, and then, okay, well, can we run the pipelines tonight? No, we can't, because Airflow is broken, and it was not nice. So definitely multiple Airflow instances, and in general, I would also do the same for any other infra you might have. So the big question, would you still do this in 2023? Yes, but no. So yes, separate environments, good idea. You sort of make sure that you have dedicated places where you can screw around and make mistakes, and a place where you run production. I'm not sure I would run 4 environments anymore. I think the cost-benefit ratio might be a bit skewed there. I think you might want to go back to 3, maybe a dev, acceptance, production, something like that. I think the added value of test versus dev wasn't that huge. I think it will also differ a bit depending on your context, what you're trying to do, how many you would need. But at least a couple of them. So we've traveled through hell again. And now let's make up the scorecard. Let's take stock of where we are. So if we look at the layers, I think the first 4, we said, yes, those are still relevant. Again, implementation might have changed slightly, but the underlying idea is still there. You still want to do this. Git enforcing is no. I think that's something that was a quirk, a weird artifact of our environment, our setup. I wouldn't do it anymore. Mock pipeline testing, yes. And then the DTAP one, I made a red check, because I was like, so somewhere in between, yes, but you would really need to change the format a bit for your environment. If we now take a slight step back from Data's Inferno, we can actually try to understand, like, how can it be that 5 years later, with all these new development tools, more people using the cloud, how can these same things still be relevant? And I think it's because these layers implicitly touch on some fundamental ideas in software engineering, data engineering, cloud engineering maybe even. Things like code integrity and validity. right? Does it even make sense, right? That's what we're testing with the integrity tests. Same for pipeline structure. Data quality is also spread out across these layers in the form of the pipeline test, but also the data tests. Alerting speaks for itself. You need to know that something is broken in order to fix it. And also separation of concerns, which is mostly handled by the DTAB layer. So now the big question is, well, can we now leave hell? Are we out of hell? Are we there now? I think still working with real data can be really hard. At the time, our sort of slogan was "real data sucks," and unfortunately, I think that's still the case. It's hard to know what to test, right? All of these things sort of assume that you have some sort of insider knowledge or domain understanding of what should we be testing. That's still tricky. That's something that you learn along the way. Most of the tests we wrote because we saw this happening. Anecdotally, I remember one case where the top 10 of richest companies in the world were suddenly all Hungarian, and that's because we had a currency conversion error somewhere along the way. This kind of war stories that adds to your test suite. It's always hard to catch every error. It's unlikely that you will. And that's also why this stacking of layers is important. Every layer might catch the error from a different perspective, and it's always going to surprise you. That was the case in 2017. I think it's still the case. I think most people still argue and struggle with this problem. The tooling is a lot better, though. If we would have had DBT at the time, it would have been a lot easier. We didn't. We made it work, and it was nice. It was a lot of fun to build. I think where we still do have some gains as an industry, as a sort of a discipline, is so can we maybe generate some of these tests in a better way? Maybe point an LLM at the data set or something and say, hey, could you figure out what fields would be risky? Or maybe some other way of generating data that sort of represents or sort of makes sure that we can see where those problems could be. So can we leave hell? I'm not sure. I do think we've made hell slightly better. So there are now flowers in hell. It still can be hellish, though, at times. So I'd like to thank you very much. The link to the repo, again, is on the slides if you're interested, and happy to take any questions.
Any questions?
Yeah. I didn't clearly understand the Git enforcing part. What do you mean by resetting it, actually?
Sorry, I didn't quite...
Git enforcing part. Git enforcing.
Yeah. So the problem there was we had one Airflow instance, so we had our repo with the DAG checked out, and then people would log into Airflow and debug their DAG. They would make a mistake or whatever, and then at the end of the day, somebody would say, hey, let's go for beers, and they would leave that code there while it was still broken. And the problem there is because we only had one environment, that meant that the production environment, the production DAG, was also broken. So the Git enforcing thing was a way to sort of prevent our DAG from erroring purely because somebody had forgotten to check in their code.
Okay, you're talking mostly about the orchestration part, basically. But
yes.
In general, it's a good practice to use the Git for checking out your code, right?
Yes. Yeah. So I think we had done that. I think the problem that we faced is we needed to allow people to log in directly to Airflow because they needed to debug. We didn't have any way of offering them a safe debugging environment. So we said, okay, fine, then go here. But that then introduced the problem of, well, this is also our production environment. So if you break things, then that's a problem.
Thanks.
Hey, thanks for the presentation. It was nice. I think most of the organizations are kind of doing the similar stuff. And one thing I wanted to understand, what is the motivation to use a single Airflow instance for the whole, different environments? What made you took that decision?
What made us is that we couldn't get any extra infrastructure, and just purely they wouldn't give it to us. I think it was a budgeting issue at the time that we had sort of gotten this. Our Hadoop cluster, so we were an innovation department at the time. So our budget was quite strict, and we already had, for an innovation team, quite a beefy Hadoop environment. I mean, beefy, I'm talking 10 nodes, so it wasn't huge. But there just was no space for us to get an extra environment. We tried, but it was a no-go.
Oh, okay, thanks.
Anyone else? Any other questions?
Maybe one more comment on the last layer.
Yeah.
Like you have different environments, right?
Yep.
I would say it's kind of decision based on what kind of environments you have. So if you are on, let's say, some kind of data warehouses like Snowflake, Redshift, I would not select 4 different stages or 4 different environments and copy the entire production in acceptance.
Yep.
But if I'm working on any cloud storage, maybe I would do that. Like, I don't think the cloud storage is that much costly, and you can just have copy commands to copy over the production data. So what do you think? Like, does it make sense based on what kind of environment you use?
Yes. I think it depends on what kind of system you're in. So we were using Hive on Hadoop. I think if you're in BigQuery or Snowflake or something like that, again, do you really need to copy? Maybe you could have a read from the production one rather than a full copy. The one thing to note is that these environments weren't sort of one-off checkouts, right? Because every time you would need to create them again and again and again, and especially that part was painful. So I think if you really need to look at sort of how much value does it add doing this. And the reason we'd made full copies was because we needed that to understand how this data was working. I mean, anecdotally, we had cases where systems would disagree on whether somebody was a private individual or not. And then you somehow had to figure out, while looking through all these tables and views, why is that? Where is this coming from? And having the full copy made a lot of sense. But it will depend a bit.
And you manage that copy as kind of CDC, or it's kind of complete dump over every day or every week, something like that?
Yeah, so the actual sources were mostly daily batches that we would get, and we would build up the history in that way. For the acceptance versus production environment, for example, we would just make a full copy. Because what would happen as well is we would flag issues with the source system, and then that would impact the data coming in, then we'd have to change those DAGs, and then it would snowball into, well, actually, we need to make a full copy again just to see where we're at right now.
Thanks.
If there are no other questions, I think we can thank Daniel. And yeah, please.
Thank you.
And I think we can already go for lunch.
It's the most important session of the day, right?
The next talk is at 1, so we'll be back at 1. Set the correct time.
this microphone, or it's already?
No, he will enable it.
Oh,
Hello, I hope you enjoyed your lunch. Welcome back. So our next speaker is Michal, and he will talk to us about an open source dbt-based platform.
So hello everyone, I hope you had a good lunch break. We will be talking today about the data value chain and what DP framework that we developed at Getting Data has to do with it. First, a couple of words about myself. I'm a data architect at Getting Data. I'm mainly specializing in delivering data platforms and data-driven transformations. My personal interests are also around data management and ML ops. Personally, I live in Munich, in Germany. So as you can see, like the reason why I live there is connected with the mountains, but not only. Pretty nice place. Welcome to visit. So let me start with the value chain. Maybe you heard something about this concept, but let's just illustrate it with an example. Let's imagine that you would like to produce something, like one thing, or maybe build a factory of something. Let's maybe imagine that we would like to have a factory of chairs or build a chair, wooden chair. So in order to have this accomplished in a way that would satisfy your customers and bring as much value as possible, you need to start from like the early question of what are going to be the materials, the sources, right? What will be the operations that would be involved to bring from A to B the materials to the ready product. Then logistics, like how are we going to ship this product to our customers? Who is going to be the customer, right? How to promote the product and build the marketing around it. And last but not least, how are we going to maintain it and actually provide a customer service. So you can see in this picture that this is a value chain for a physical item or a physical product. But why we are introducing this concept? Because it has also something to do in the data world. So imagine the same guy that comes up with an idea, let's have a dashboard or a KPI, right? So he's going to probably start with the same process, like how we going to, start like collecting, acquiring data, and then how to clean the data, pre-process it, then integrate this data probably with other sources, then make some data analysis on top of it, and finally create a product that would be useful for other teams, for stakeholders, customers, right? So you can see here that this could be an example of a data value chain. What I really like is this kind of illustration and perspective of a data value chain that is not only focused on the product, on the product creation, on the production side, but also covers like the use of this product. So it's not going to be very useful when we produce a report and just keep it on our like a local machine without any people having access to it, right? Knowing that we have a cool product, a cool data product. It's the same as with the market that sells chairs in the middle of nowhere, not knowing, with people not knowing that such a wonderful place with great chairs exist. So as you can see, here data value chain involves not only the activities related to collection and publication of a data product, but also with the uptake and managing the impact of it, right? Let's maybe just zoom in a bit and try to imagine like what such a data value chain would look like for BI products. Let's imagine that our CEO or some stakeholder came to us and requested that we build a KPI report, right? So what is the usual process? So we are starting from okay, creating a project, then we search for the data that would satisfy the requirements for this KPI, then we set up some ingestion to our warehouse, database. We develop transformations. We can think about dbt, for example, as a tool that we develop these transformations in. Okay, we are happy with the model, we publish the model, we build dashboards, and that's it. That's the final product. But it also sounds like, creating a chair in your garage, but without any thought about how to scale this, how to, make this whole thing work in a bit more complex environment. So dbt is actually responsible for this part of the process. We are, for the moment, not taking into consideration dbt cloud, but I will explain in a bit more detail why in a moment. But what is missing in this picture is what if a customer would like to integrate these transformations with some advanced or native schedulers, like, for example, Airflow or Databricks workflows. What if we would like to also automate and provision some way of defining the connections to the source data, like, for example, Airbyte jobs, right? Or any other jobs that would bring us these materials to actually our workshop, right? So we need to have that kind of item addressed as well. Like how to make data searchable for the next project. So imagine that we created a report, a data mart, and we would like the other people to know that we actually have this cool data product and that they could leverage it, right? And how to standardize the data projects and foster engineering best practices. It means that we don't want to reinvent the wheel every time we are about to create a data project. So as you can imagine, a lot of things are in common between different data projects. So there is a temptation to you think about maybe we can just put some of these repetitive steps into some kind of a template and not start every time from scratch. And last but not least, how to create a robust modern working environment for the users, right? So as you can imagine, with the example with the chairs, right? So you need to have a proper workshop to build a really good product, right? So here it's the same with the workbench, with the environment that is like everyday tool for our analytics engineers or data analysts. Having this in mind, we developed a DP framework, which is actually a collection of open source utils that support this whole data value chain. And in a moment, I will explain a little bit more what this DP framework is all about. Okay, so in the heart of DP framework, there is a library which is called Data Pipeline CLI. What is important to know about this is that what are actually the reasons why we actually like decided, okay, let's build some tool that would help us to automate some of these repeatable items, because like we usually face the situation when we had a very similar project and we dealt even with a very similar stack. But we often had to hire our data engineers, sometimes very senior data engineers, to build the whole processes, to build the whole CI/CD, and introduce best practices. So we felt that there is like some redundancy in this whole process. We also like realized that some of these tools created on the projects were very specific for a particular environment. They were not very generic. So it was clear for us that every engineer introduces something that they are fine with, but without thinking about introducing some flexibility. And last but not least, right, we realized that some of these items in our pipelines are not very friendly to our analytics engineers, so people who are mostly with SQL background. So as you can imagine, if you build a big factory for producing chairs, you don't want to have only the senior, most experienced carpenters involved in creating chairs. You need to provide some environment that would help to create this high quality chairs, high quality products, even with less experienced people, but without compromising the quality, right? So I will just go through the three main items of this framework. After I show you what are the main features, I will demonstrate this in a short demo, how does it look in practice. So as I said, the core part of our framework is Data Pipeline CLI. So this is a single place to interact with the whole pipeline, which allows us to interact with DBT, with the project templates and data ingestion tools, and it also abstracts and hides provides the level of abstraction and hides complexity from analytics engineers. So analytics engineers do not have to know all these fancy command line expressions connected to data engineering stuff. So a lot of these things have been simplified for them. The next thing is which we call the factory, that is actually translating manifests from DBT to the preferred scheduler. the orchestrator. There is an asterisk here in the name for a reason, because depending on what is the scheduler, we have a dedicated library, whether it's Airflow, whether it's Databricks workflows, whether it's like GCP workflows, for example. So there is like a dedicated package which simply on the fly, without materialization, builds a DAG out of the metadata generated by dbt compile, right? So this is very, very helpful, because you don't have to know, like, for example, Airflow DAGs are created. So not all the analytics engineers are experts in Airflow. All you need to do is just to properly configure the relationships between the models in your dbt project, right? So when your dbt project like supports these dependencies, then it's very straightforward to transform this logic into, for example, Airflow tasks. And what is also important, that the test steps are also included, as you will see in a moment in a demo. The last thing from the DB framework I would like to share with you is Project Template Factory, which is actually a way to standardize projects that deal with the same stack, with the same type of data, for example. So we are utilizing here a copier library from like the Python library, and we are just at the initialization of the project collecting all the necessary information, like the project ID, like the username, which then are like used to create a project structure that will bootstrap the project, and all the analytics engineer has to do is just to provide the definition of the models and some simple configuration. So this brings me to demo number 1. And oh yeah, that's it. All right. So demo is pre-recorded for like one specific reason, because there are some steps that take some time. There is no magic in it, no worries. So I will just, whenever there is something that I would like to talk about in a bit more detail, I will just pause the recording. And I will start with the workshop, right? Our data carpenters workshop. So like there are two things we created that are on top of this framework. Like one is called the GID portal. And this is like a marketplace for all the apps that are available for a user in order to interact with the data environment. So from here you can like choose like which project, like for in this particular example it's GCP project that you would like to use, and you can like from here navigate to your apps that you have access to according to IRM roles, for example. You can like create a GitLab project, you can go to Composer, Data Hub, Looker, Airbyte, and so on, depending on which project you're using, right? So this is like one thing. And we are just like going now to here GCP, trying and creating a workbench from an image. And it's a Jupyter Lab. And here I would like to mention that it's not necessary that you have this whole environment from within Jupyter Lab, because sometimes it's easier to work locally. This is a really cool thing that if your client requires like some sort of isolation, like cutting off from the internet and so on, you can like embed like all the settings, all the security within an image, and let people only spin up like images, like for example, using like some Kubernetes clusters. But of course, if the company allows, you can also do this on your local PC and use like the VS Code or PyCharm or any other favorite IDE for developing DBT models like from your laptop, right? So here in this example, we are using the image and the Jupyter Lab. So we're gonna start from initializing our template manager. So the template manager is basically a very simple repo where we have a list of templates available for a particular team, let's say, right? So then we are cloning pre-created repository in GitLab, and then we are using dp-create command in order to create a project. And here we are choosing a template from the list. Let's say we would like to have this template, and each template has a list of questions. It's gonna be a wizard where we are just like answering some of the questions. What's the user, project ID, cron schedule for Airflow, and it's like pre-configuring the structure of the project, and this is something that you can see on the left. So this is what this copier wizard created for us, okay? So what is quite important to notice is, for those of you who are familiar with DBT project structures, I will only mention a couple of things that are very specific to what is created by this template manager. So here, there are configurations for different apps in the stack. You will see in a moment like what kind of files are in each folder, and they are stored separately for each environment. So there is like some base folder in which you have like some default configurations, but also you can overwrite these configurations with dev, prod, whatever kind of environment you would like to deploy your logic to, right? So here we're gonna start from Airbyte and from showing like how this is like the configuration of Airbyte, and this configuration is provided in order to create connections in Airbyte, right? So the connections are also provisioned based on like what is defined here. This is pretty useful when we have an environment where we don't have to ask data engineers to provision data for us, right? So this is like a very self-serve approach. As you can see, like in Airbyte, we are just like getting our data in order to process it further with some DBT models. Okay. So this connection is provisioned. And also this step is part of the workflow in Airflow, as you're gonna see. So, so the sync is successful. And now we are back to the project. So here, for those of you who are not familiar with DBT, now we are just like showing where the models are defined, but I think that there is nothing fancy about it. This is just an SQL code. And we have our data already loaded, right, with Airbyte. So the next step, when we develop things locally, because we are talking about local development, we just use dp-run. dp-run is very similar to dbt-run, but it's actually under the hood also compiling the project and checking the dependencies and so on. So you don't have to remember about all these commands yourself, right? So as you can see, the models got created, and now we are running dp test. It's like very similar to dbt test. So we are just like checking if every test goes successfully. And then we are checking the documentation that was generated, also locally, and the lineage. So once we are happy about our local development, the next phase is to deploy this, right? So we are initializing a merge request, and which will trigger the CI/CD pipeline and deploy our DAG to the chosen environment. For this in this particular case, dev environment, right? So as we can see that this is the pipeline in GitLab. And now we go to Composer, and we check that our DAG got created and run. We can run it, right? So, yeah. Okay. So we're going to get back to the DAG in a moment. So now let's just show another piece of the stack, the data catalog. I'm not quite sure how many of you heard about Data Hub project. In terms of popularity, I think it's one of the most popular like metadata platforms that is open source, right? So we heard about Colibra today, about Alation, but these are like the proprietary quite expensive products, but maybe for some customers it makes sense to just offer something open source. Of course, you need to provision it, but it offers a lot of great features, as you will see in a moment. So some of these metadata items are provisioned automatically within like DAG run. And some of them you have to ingest yourself in like CI/CD pipelines. But here is just an overview of what kind of things you can expect from Data Hub. As you can see, this page is quite interesting because it shows a history of data tests. And these are all the DBT tests that are configured for a specific table. So as you can see, everything is green now, which means that like all the recent test runs are green. So this is also happening once you run the DAG. So this results are pushed to Data Hub. Okay. And you can also see the lineage. So the difference between the lineage here and the lineage in DBT is that you can expand this lineage to the items that are not processed by DBT. So you can imagine that in the DAG definition, you can add some extra piece that is, for example, doing something with the data product, but this is not like happening in DBT. So Data Hub will capture this, DBT lineage not. Okay, so some zoom in for the lineage. Of course, column level lineage is also available. And here, yeah, you have the configuration here. So once again, I'm just like showing you like the content of the folder. And here are like the two configuration files responsible for how we are dealing with Data Hub. One thing that I would like to mention is that you can tag the data automatically based on some rules that you defined here. So for example, here we would like to add a tag to each data set that this data set was created by this particular project. So you can define a lot of different configuration rules over here. You can also specify whether you would like certain data sets to be profiled. Profiling can be sometimes very pricey in terms of like using the resources. So you might not want to profile like each data set that is in the data warehouse. So here is the place where you define the rules. And so on. I will not go through all those options, but as you can see, it's pretty powerful configuration for the data hub ingestion. Okay. So we are at the last piece of stack that I would like to show with you. It's integration with Looker. So in here, what is quite important is that this feature is like I would say like private preview. It's not really like working on the production scale, but we are trying to generate the LookML files in order to speed up the creation and management of the dashboards based on DBT models. Okay, we are getting very close to the end of this part of demo, and there will be another one, very short one. Okay. Okay, the last thing about this one that I would like to show, you see that in the right lower corner that we have some notifications coming. And this is something that I wanted to leave for the end of this demo. In DBT, Airflow Factory also has a feature of configuring Slack notifications and also MS Teams notifications. Whenever something fails, we are receiving a notification. And we can check like in the Airflow what really happened. So it's not like any black box. We can actually go to the logs and see that one of the tests failed. And we can see now in like Data Hub that one of these tests failed, and we can see here like some history of that. Yeah, all right. So that was the demo. I have 2 more slides. Oops, I just didn't want to do this one. Okay, there we go. Okay, DB framework and Databricks integration. So I just want to share with you where we are right now, because as I said, like we are working with different platforms. I presented like the integration with BigQuery, but in terms of Databricks, we developed a POC which also handles the automation of flows which are run on Databricks. So a couple of assumptions. The solution is supposed to use Databricks SQL warehouse as a data storage and workloads for orchestration and execution of DBT pipelines, right? So another thing that we would like to do is to integrate this with Unity catalog that we already heard a lot about today in the morning. What is also very important to note, to mention is that as we have DBT Airflow Factory for Airflow workloads, we also created DBT Databricks factory that is responsible for translating DBT manifest into workflows tasks in Databricks and using REST calls to Databricks API in order to create these workflows. This is something that is still work in progress. So I'm just like indicating here like what kind of features we would like to work on in the future. So we would like to further automate this whole solution because it involves some manual steps, a little bit more than in Airflow Factory. We would like to also integrate this, as mentioned before, with data catalogs, especially Unity catalog. We also are working on some smart like cluster management solutions and analytics workbench for Databricks. There is like, I don't know if you have enough time for the second demo, which is going to be a little bit shorter, but I will maybe do some cheating here. I will maybe put it like 1.5. I think it's still something that is worth to see. So this is something that we already know what's going on, because this is initializing of the template manager. We are creating a project. We are calling dpcreate with this particular GitLab project. We choose a template, and we have specific questions for the Databricks, right? So apart from giving the username and project name, we are also specifying which cluster we would like to use to execute the tasks. So we take it from here. This is a cluster we provisioned like manually before. Okay. Yeah. All right. So the structure got created as in the previous example. We are running the VS Code locally, now not from the Jupyter Lab workbench. So as you can see, all these configurations specific to Databricks got to the folder config base, and this is going to be important when communicating with Databricks. So there is some model here and docs, which is not very original here. Yeah. We compile the project, and as a result, in the build folder, we're gonna see the files. Okay, we see the JSON file that is a representation of the workflows. Okay, so now it's the time to deploy. Once we deploy, we should see in the workflows our workflow. Yeah, we can run it, and you will see that all these tasks here are the ones that correspond to the DBT models that are in our DBT project, right? So as you can see, like all these configurations, like which DBT models should be run are available through the UI as well. And we can see the logs of each of the tasks. All right. So here, the last thing in this demo is just to visualize like this models in DBT, just to see like how does it correspond to what we have seen in DBT workflows, in Databricks workflows. And yeah, so that's it. All right, so I think we can just move on to the last slide. Let me just stop this one. So this concludes my talk. I would like to especially encourage you to check like our projects, and I would like to also to hear what you think about this integration, and if it's something that you feel that might be useful, especially on your projects, or you might think that maybe it's like not going to work ideally with your clients. And yeah, thank you, and I'm open to the questions.
Thank you, Michal. Any questions?
Hey, hi. I think it's quite nice that you generate the task level, from the model level tasks, not the whole pipeline at once. So I think that is quite nice because a lot of our database customer use dbt and they complain about that we have only one job and it runs the whole project and doesn't show the task level, model level tasks. So I think that is quite nice. One thing that I want to understand that there is a open source library called Elementary for dbt that is kind of monitoring and observability. If we use that as a dbt package, and I see that you do dbt depths in between the run, so it includes that package, but then it generates some reports, and to generate that report we need to run a command, something like EDR run basically, which is not a dbt command, and that fails because it says like, it's not a dbt command. Generally it happens with Databricks. So do you have any thought about it, like if someone tries to use that third-party libraries and the commands for those libraries doesn't resonate with dbt, it's a separate command that they need to run. Is there any plan like can support those kind of stuff?
So to be frank, I heard a lot about Elementary. I was playing around with this library, but never incorporated this in this stack. But I can imagine that whenever you serve this kind of UI, because I remember that there is like some UI involved, I can imagine that this could be also somehow refreshed in CI/CD, but I just don't know like exactly the solution that could be here incorporated. But like for the local development, as you saw, we are using like dp docs or dbt docs generate dbt docs serve, and we can just observe how the things go. But I think it's with the Elementary could be the same, but I'm not quite sure about like the deployment. So.
Yeah, basically it generates, I think, some XML files, like how docs generate the manifest JSON and the run result JSON and then the doc stuff. So it generates similar stuff, but the only difference is that it has a separate command, which is not a dbt command.
Yeah, so I just remember that when I was wondering about this topic, I was just like not sure how to like serve this UI, right? So you need to just like, push it to some kind of endpoint in order to see all these anomalies, additional tests. So this is something I have not figured out yet, but I think we're just going to get there. Yeah.
Okay. Thanks.
Any other question? If not, then thank you very much.
Thank you. Feel free to approach me if you have any specific questions.
Gift? What? I'm not sure what's the gift. Yeah. All right. Thanks for this indication, because I got lost in this demo first. I mean, like, I thought that I have a lot of time. All right. How to untangle from this?
Oh yeah, I think they can help you over there.
All right.
Just take a laptop.
We'll just take this.
I think we need. This is yours.
This is mine.
Okay. Yeah, Rob one and then.
Okay.
Yeah, it's. So now let's. Okay. Let's welcome Steph and Alex, who are going to talk to us about Rabobank's journey from Hadoop on-premises to Azure Cloud.
Bueno, dale.
Nice.
Nice. Okay. floating. Don't float away. Wacht even tot de deur gesloten is. Yeah, we can go. Nice. Welcome for this invitation and to this presentation. My name is Stef de Moor. I work at the Rabobank as a product owner of OneLab. And here on my left is, present yourself.
Yeah, Alexander Bij, data engineer at GoDataDriven. Well, actually, Xebia data now. Yeah, it's still. Can you? Oh, yeah. Yeah.
Zo heel spannend.
Maybe arm length away from each other.
1.5 meters. It's still in. Oh, wow.
Yeah.
I thought we got rid of that COVID stuff, but
yeah.
You stay there. I press the buttons then.
Yeah, that's good.
Cool. We have a little agenda for today. I can read it out loud, of course. You can see it here. But we start with a small introduction. It's a little bit scary here on the... My name is Stef de Moor. I have a degree in industrial engineering. It has nothing to do with banking, more with big machines and stuff like that. But, sometimes you end up in the financial industry. For over 17 years, a little bit over 17 years. I started out as a quantitative software management consultant for a company called QSM for project sizing and estimation of software products. That kind of bored me in a way. It was statistical, that was the fun part, but it was quite a difficult product to sell within a corporation, especially to the stubborn project managers who did not want to listen to you. Their planning was leading, and what you said to them, that was not right. Gradually, I moved more towards the reporting and analysis, and that's more or less the common path that I walked throughout the Rabobank. Joined the analytics environment, the data science environment, over 7 years ago. Started as a data engineer, doing stuff with the big data. It was called big data at the time. Went more of a Cloudera engineer. Worked with the company that was at that time known as GoDataDriven. Worked with some of the colleagues of Alexander in previous years, building up the platform. And moved later on from solution architect from the data lab to a solution architect of OneLab. And I wanted to give direction. So when the opportunity came to be the product owner of the platform, I was the first one to jump in.
Yeah, nice. Alexander Bij, as I said, GoDataDriven, but that was when the name was changed into Xebia Data. And before that, I was actually already working at Xebia. So I was also looking up, like, okay, how long am I actually working there? But since 2011, it's already for a long time. Yeah, so Stef wrote this engineering and boss, so I really liked it, so I kept it there. Didn't replace it. Yeah, it was a placeholder, but I really liked it. So I'm working here for a long time. Very happy at the company, and I'm working at Stef's team for I think 1.5 years, something like that, helping towards the last part of the implementation, let's say. Yeah. For the journey. Yeah. So
what I'm going to do is tell you a little bit of a story of what it is, what the vision is, and the more technical stuff will be covered by Alexander. I'm for the talks and the presentations and the PowerPoints, and Alexander is for the nitty-gritties. So if you have difficult questions, go to him. If you have easy questions, I'm tempted to ask them to answer them. A little bit of context. Analytics is of course all around. And as a bank, we also want to jump that bandwagon, of course. We need to innovate. We want to innovate. We need to support stuff that is has to be done by legislation, but also stuff that makes our life easier. The process improvements, and also, we're a bank. We need to make money, so also marketing. What we try to do with OneLab, we try to focus on having a solid research and development platform to enable productionization of your ideas. I will come back to that in the next slide, but what happened in the past is that there were great ideas, a lot of great ideas, but it took ages for that great ideas to eventually end up in a productionalized environment. And that's sad. That's how good ideas sometimes don't work out. And a little bit of the history. I didn't start in 2011. That's a little bit prior to my intervening with this platform. It's like always you need to end up in a Gartner quadrant to be noticed by a board. So it was literally that Gartner said you should do something with Hadoop. And somebody at the board said, yeah, we need to do that. So they made a little bit of budget. And well, they actually bought a couple of servers. It was a handful, and they were undersized. That was what that happened in the later stage. We found out that they were undersized. And it was just experimenting. What is it? What does it? What can it do? And can it provide value for the Rabobank? And then we started to grow. There was a growing number of data scientists that wanted to do great stuff. The knowledge was not within the Rabobank. So we hired... Well, we didn't hire Alex, of course, because we didn't know him by the time, but we hired some people from GoDataDriven to help us out with finding ways of stuff that you can do with data. And with that came the increased number of worker nodes, so it became more and more a platform that actually could perform. And then the name Data Lab got born. And at that time, what we did, or what people did. I was more in the engineering part. I came at Bay in 2016. That's where I entered this area. There was ad hoc research and some, predictive analytics. And I vividly remember that one of the projects that ran on the lab was, okay, if we have networks, and I mean the infrastructure networks, not, I see Hilke there, not graph networks, but infra networks, and we have machines. Can we, for some reason, predict when a system, starts to fail? It was very successful in a way that we found out that it was mostly human error that caused incidents in the landscape, updates, the certificates that got expired and stuff like that. So that really did not really fly. In 2017, other departments came knocking at our door, and they wanted to do something with big data. And we were a small team. I think it was like 10, 15 people. We went a little bit rogue. We bought IMAX to connect to the Cloudera cluster because, IT couldn't provision. So we had made a deal with the Security Operations Center that if we plugged in an iMac in the wall socket, that they did not come running into our office and say, hey, we found a rogue device, what's happening? But that was not maintainable. So we needed to do some investigation. Okay, how can we, enable users to work with our analytics platform? And we bought a tool, and Hilke came into play. Yeah, sorry, Hilke, you're now my guinea pig. Came into play at that time with a nice data science product that made it available to leverage the power of our Cloudera platform with the ease of use of more drag and drop tool. And it was great. That gained traction. The environment grew. I think we ended up with 60 nodes, 60 worker nodes with 1,600 CPUs, 2 petabytes of storage, and 11 terabytes of memory, somewhere in that vicinity. But what happened is that people were unexperienced. First, we had a data scientist who knew what they were doing, and then eventually, we got people who did the select star, and we got the noisy neighbor issue. But at that time, also PySpark came into play. PySpark was already there, but Cloudera was lacking a little bit in implementing the great version 2 at that time. So people were, experiencing, getting really happy with the platform. There are actually some products in our app that originated from the Data Lab. I don't know if everybody uses the Rabo app, but has the...
You mean the app?
Yeah, in the app. It actually is in the app. It's the name checking. If you enter an IBAN and a name, that was supported by the lab. If you have the
forecast.
The forecast of expenses and incomes that originated from the Data Lab. So, that's kind of cool stuff that was happening there. But it took a long time from that stage, that data science, that exploratory stage to get into production. And then at the end of 2019, or in 2019, we saw the data gravity moving towards Azure. Yeah, and then, of course, you also need to move. Yeah, you want to go where the data resides. So in 2020, OneLab was born. One of our business architects came up with this idea because in the bank itself, on premises, there was a lot of shadow IT. People just ordered servers for data to do processing and everything. And he saw this as the golden opportunity to consolidate, to have one platform where we could, onboard, and not all, that will never happen, but we can onboard most of the people to actually do great stuff with data. Data science was our first real client, and since they were already familiar with Jupyter Notebooks, they were familiar with Spark, Databricks was the primary choice at that time for this specific use case. The other platform is also available, but I will show it in a later one. Yeah, also on later slides. Last context slide. You see here we have what we call the global data and analytics platform ecosystem. OneLab is the part that I'm responsible for and where Alexander is doing a lot of cool stuff in creating it. We consume data from the global data platform. That's where the data resides. For fast or seamless productionization of models, we are building a so-called model serving platform. And last but not least, not everybody makes models. Sometimes people just want visuals, just a simple dashboard. We are also working in conjunction with our BI area to make a seamless productionization of dashboards that have been created within the lab and with all the shenanigans that go with it.
We need to explain the arrows a little bit. What goes where?
Yeah, they go all over the place. This is an architectural picture. I stole this one. Now, architects tend to make pictures that really need explanation. So there are a lot of arrows and stuff. Now, it's just, the thing is, as a lab, and then we are kind of like already jumping to next slides, we only consume data. We are not producing data. So it's really and merely for experimenting. We want to prevent users to have production runs within the lab. That's not what a lab is supposed to be for. A lab should be able to explode. That's how we say it. It can go boom, and you can give me a new one. So the model serving platform, it's more, what is described there is more, you have an artifact, a model artifact, and it just hops over a line and runs into production. So that's more what business architects use to make a good impression. My vision, what I eventually want to do, and currently people can only use more or less Databricks. What I want to do is to empower employees to do good stuff and crazy stuff with data, especially in a standardized environment where security is of the utmost importance. I don't think that everybody or anybody wants their data somewhere to be found on the internet. So one of the things that is on the top of our mind, and it's one of the most important things, is can we do it safe? If we cannot do it safe, it's not going to happen. What we also support is experimentation with new tools and techniques. We're currently implementing a Neo4j solution for people to work with graph databases, and we also provide a very controlled OpenAI gateway. Because we want, as a bank, we want to learn what goes in, what goes out, where data is stored, because that's also one of the scariest things about OpenAI. What do they do with our data? And also, of course, cost. Those large language models cost a lot of money to be created, and they need to make it somewhere. So I really, as OneLab, also want to help people out with these questions. So what do we have so far? We have a so-called low-code environment that's called DataIQ. That's an IA solution, which hosts approximately 500 users at this time. Yep. It is a data science workbench, drag and drop. I said a clickety-click. People who have low code experience, they can easily onboard on this and do their stuff. The thing is that we will not productionalize this. This is merely for experiments. On the other side is what we call high code environment, and I know there are levels in there in high code. We offer a Databricks. So what we do is we deploy Databricks instances for users at their disposal with a little bit of storage, so that they can connect to that top left bar that you saw in the previous slide to the GDP and consume data there.
Yeah, and maybe something about the OSVD, right? It's keep.
We're too close. Sorry.
Yeah.
Proper distance.
Yeah.
Yeah.
No, and maybe something about the data IQ. That platform was also used before on premise. So it's moving towards the cloud, and this is the cloud solution of the data IQ platform. Yep. So people who have been using it on premise can now also work in a new environment in the cloud.
Yeah. So they're a little bit familiar, so they don't have to learn new tricks. And indeed, I mentioned the security prior. To enter our lab, we have a stepping stone that we call a OneLab Secure Virtual Desktop. That's a virtual machine that lives within the vicinity of the lab. So you cannot enter the lab from any device. You really need to log into the device first, and that is your stepping stone to your specific resources, not all the resources of other people. It's your resources. How are we organized? Yeah, the buzzword Scrum, Agile. We have the radio. That consists of 7 people, including a Scrum Master and a Product Owner, and they merely focus on data IQ, keeping it up and running, onboarding new users, and supporting existing users. I have 2 squads who build the great stuff for OneLab. They're about 11 and 8 in size, and they primarily have their different focus areas where one team is focusing on the deliverables with the people, that stuff that people actually use. For now, that's Databricks, but there will also be stuff like SQL, Azure Machine Learning will come into play. Maybe Microsoft Fabric will be one of the offerings that we provide in the future. And the other team, that's Jupyter, that team will focus more on all the stuff that is around the lab, the security, the firewalling, the secure virtual desktops, how to get data in and out of the lab in a secure and controlled way. And last but not least, I always want to mention our support hero. One of the engineers or one of the business analysts has the noble job of being a support hero for a sprint. And then he or she will interact with users with requests and how to work on the environment. This will eventually move to a different squad, because now we're focusing on the Netherlands, Rabobank Nederland, and in Dutch-based Rabobank International clients, the WNR. But we will swiftly also move to North America, Brazil, and New Zealand and Australia. And I always opt to go there. You need to meet people in person, but I don't know if that will happen. It's against policy, something with carbon emissions.
I like it also that the planets are equally sized, right?
Yeah, that's my autism, sorry.
Yeah.
And really, it's not like that. It's just...
Yeah.
Off to you.
Yeah, maybe it's also nice to show a bit, okay, what have we built and what is now there, instead of only the high-level overview. So I want to dive in to the depth of the OneLab a little bit, explain the picture here, which is actually created by Steph. So thanks for this nice overview. So as Steph already explained, you cannot go into the lab with your personal laptop, even the laptop from the Rabobank. It has been decided that it's too big of a security risk that you can get data out and email it or whatever you can do with it. So you have this device in between, which we call the OSVD. So I have been at multiple clients, and that is a common thing for places where the data is very sensitive. For example, the Dutch police, that was also the way of working, that you have your own device, which is in the isolated environment, and from there you can access production data. The OSVD, it's a Windows machine, right? There's pre-installed software, so you have some office tools. Of course, your OneDrive will not synchronize to the cloud automatically. You will not have email there to or chat. You cannot chat with people there. But of course, it's a virtual desktop on your local machine. So you can close the virtual desktop and then search something in Google or look something up, email, and work with others. And within the environment, you can access the data. And then you're thinking, yeah, but I can just copy data in and out. But there are limitations on this VM that you can only copy in like 2 kilobytes of data and get like 1 kilobyte of data out. So that you at least can copy paste something that you found on the internet or your code that you need to fix, but not actually export a large amount of data. And then you think, yeah, but I can always take screenshots. Yeah, but there are even watermarks over the screen. If you have this page open, there are very light watermarks that you actually are working on this OSVD. So if you take a screenshot, and we will find out who it was. Yeah, of course, you can work around it always, but we try our best to make a secure environment, because you cannot only access, like in normal bank applications, a record which is for you. There's bulk data in there. It's just like, okay, you get access to a data set, and you get everything which is in there. So I can explain that a little bit later when we got to the global data platform, the GDP to the right. I thought maybe it's also nice to give a bit of the context of the size of this global data platform. Do you know how many squads are working there, right? Because we are more or less 4 squads to get this thing up and running.
I think more than 2 handful.
Yeah, I think more than 2 handful, more than 20 squads is the complete global data platform.
I have 5 fingers on my hand. 2 handfuls, more than 10.
More than 10. Yeah. So to have a bit of a comparison, this global data platform is huge. That's also Rabobank-wide an implementation to have a place where the data is available for consumers. And OneLab is one of the consumers of the data. So in the global data platform, can quickly touch that. That's also an Azure storage account, maybe a couple of them, with only 2, let's say, layers in there, like a raw, and they call it defined or derived also. And there is people who have data on-premise, various sources, can be producers to put something there on this global data platform, and are the owners of that data. So the tool Colibra is one of those tools that is the one who arranges the access. So you can request access, and if you get access for your lab is then tied to a single Active Directory group. Each lab has their own Active Directory group. You can request access. Do I lose my sound?
Yeah.
Then we
Talking
can,
this.
we can stand close together.
Oh, but he's going to fix it now.
Okay, yeah.
I hope.
Yeah. We can also...
Oh, yeah. Ooh, you're going to get the mic.
Get the mic. Yes. Okay. I think I was at the global data. Ooh,
exactly.
This feels really professional. Yeah, nice. So, the global data platform, there are multiple layers with the data sets. The people who put data in there are the producers, and the people who want data are the consumers. And each team has their own Active Directory group and can register themselves in the tool as a consumer, request for access. And the owners of the data can say, okay, you can get access for a couple of months or weeks to this data set, and then you can use the data within your lab. Yeah. So in the lab, that is actually, I was explaining the blue arrow in. There's also a blue arrow out, but actually there's no data going out from us to the GDP. I hope there's no.
No, it's not data, but
it's not data.
When
there's a connection.
There's a connection, and for model validation, you need to have model data sets ready. So that's more or less that, but that's not for general consumption within the bank. No.
Yeah, and good to know. Technically it's possible, because if there's a connection to the storage account, and if your group has the access right to place data, then you're a producer. But let's say by the rules of the system, it's not allowed. But technically, of course, we are connected. There's just AD validation. It's possible. Something else what's fun to say here. On the left top there is, right top there's this OneLab user documentation. So of course we have quite a lot of users, and not all users are very technical, as you have said, or are from the original data lab, yeah, they need to be guided, and we have experienced that it's very important to have a good, yeah, let's say the wiki page where you can find how it works, how you can request data, for example, from the global data platform, what are the limitations of the platform, what is possible, and how to get help, and have a good wiki. So if they face issues with their OSVD, can I install this or that? No, you cannot. Internet is blocked. Yeah, you can request some things, and then we can scan it and check it, and then put it in the goodie store. There, of course, we make your life hard, but we try to facilitate the users. I think I am back connected. I'm not sure. Okay, yeah, and there are some gray out icons, as Steph mentioned. So we have now the first version. Databricks is running in a secure way. I want to say something about secure environments. And data IQ is there. You have a storage account, but we want to focus on more Azure native tools to support the users. That's the plan. Yeah, facilitate the users. Yeah, so, and we have a bit, it's not a slogan, it's a mandatory thing. It's, the goal is to make sure that no data leaves the lab. And yeah, I want to, for example, there's this project, they have this Databricks environment, and Databricks is just an example, but of course you can have different services in Azure, but I took this advantage, this opportunity to explain Databricks. So you are working on the OSVD, and there's this Databricks environment, and yeah, of course you want to allow the OSVD to access this URL. Each Databricks environment has this URL on the internet. Everybody can access it. Yeah, and Mr. Hacker should not access it. Yeah, you think like, oh, that's simple. I just add the user, and if you have your authentication, then it's okay. Yeah, yeah, that's true. Yeah, that works. And what if they have a token, and this token is valid for 90 days, and the token is leaked, and the token is just get access to Databricks, all the APIs you can call and do whatever you want. So you also want to prevent these kind of scenarios, that some token or some access is leaked somehow, maybe on purpose, maybe not, and should not be able to access from the outside our Databricks environment. Yeah, yeah. And the hacker can also do this. He can also say, well, I create my own Databricks environment. We call it my own data copy environment, and I have my own URL. And yeah, what you do not want is that people from the OSVD can also access the other environment, maybe from another bank, right? I'm going to work at this company, put some data there. Good luck with my transactions. So that's also what you want to prevent. Yeah. Any idea how we can do that? Private endpoints. Private endpoints. IP control list. Yeah. Good answers. Yeah. Exactly. Now another example. Here, this hacker felt like, let's put something in this pipey.org, right? That's just a public repository. I can create my own package. Put there the package, I invented a nice name. Your data is mine. It's a new package. It's great for data science. Your data is mine. And you put it in pipey.org. Feel free to just post it there. It's possible. Yeah, what you not want is that people can consume packages that are infected with things, right? Leaking private keys, leaking data. This is just an example, but it actually happens, that people put packages in this pipey which are harmful. Yeah. So you want to prevent Databricks that you cannot say, pip install any package from the internet, right? Yeah, maybe a good solution for this as well. Yeah, a private package repo. Yeah, so we say, okay, anything that goes into this lab, no matter what it is, it should be scanned for vulnerabilities. And exactly, you can use a private feed to facilitate this. It's not only the private feed, because you also need to make sure that you have scanned the packages. So imagine that you just let all the packages in. There are also packages with specific, licenses. That said, if you use this package, then your code must also be open source and you share it with the world. Yeah. Even a network user who interacts with your product is allowed to see your source code. Yeah. So there are licenses of those, this AGPL, BLA3 license. But by default, you want to block those packages. So like, okay, those crazy packages are forbidden. Yeah. So and you should scan whatever comes in the lab. I think that's the main goal what you want to do. And there's software for that, of course, and products. But yeah. So no data leaves the lab, and no risky things come in the lab. Okay, let's see. I think you scored quite a lot of points. So what kind of measurements do we take? So of course it's behind AD authentication. That means you need to authenticate yourself, that you are this person. For example, conditional access policy. That means, okay, you want to go into the OSVD, go into Databricks. You have a conditional access policy that the device you're accessing the product needs to be a compliant Rabobank device, right? With a sticker on it or a virtual sticker. Like it's not a random device in the internet. It's actually known by the Rabobank. Conditional access policy. I heard the IP access list, bonus points. For example, the token, by default it's 90 days. You can also say like, okay, just 1 day token. Have fun with Databricks for 1 day with the token to reduce the factor of when it's leaked, it can be misused. Yeah, also firewall. So we provide the platform, but we also provide the network around it. It's disconnected from everything. It's from the Rabobank on-premise network. It's not connected to anything else. So we also control the network, which is a hub-spoke network with the firewall. And we also have this firewall where we control whatever is possible and what's not possible. So from the OSVD, we also only allow the Databricks that we know. The rest of the URLs of the internet are blocked. Yeah. Private endpoints, more points, private endpoint. So that's a feature of Azure that you say, well, this thing is totally hidden from the internet, and you only make somewhere a network cable, put in an IP address somewhere in a subnet, and there is actually the entry point to your service, which is a private endpoint. Yeah. So that means the service itself is not available publicly. Yeah. Also sometimes makes it hard because you also have automation and you have like build agents, and the agents also want to reach those components to configure them with infra as code. Yeah, so you need to have a good balance of what can reach it and what is blocked. And scan anything incoming code. That's for general. All the data scientists want new packages, they want models, spacey models. Every day there's something new and they want it all. But we have to rule that, okay, we first scan it. And of course you need to automate it because it's a lot of work. Yeah, so that is a bit of an example how we try to make a secure environment. That's also why it's not so easy to just say, oh, we add another tool. Because you have to think of the risk, like, okay, how do we make sure that we don't leak data, or we try to prevent it. You cannot say, oh, we just add Azure ML and we'll see what happens, because in there a lot of things happen, and you need to understand it and see how it all works. See if it supports private endpoints, if we can use that. Yeah. Okay, there was a bit of an overview of how we try to keep the labs safe. So how many users do we have? A bit of stats. So every time we have a sprint demo, we try to give an overview of, okay, what's now the current usage of one lab. So on the ugly donut chart is the amount of labs that we have deployed. So that are concurrent labs that are more or less next to each other. So that's quite a lot. So we have different versions and we can upgrade them and have new functionality in the labs, like various things. And so we already reached 120. So that's quite a lot. I'm hoping to reach 128 soon. Then it's a nice round number. Yeah. Yeah. Yes. What? Yeah. Yeah. And on the right is actually all the people who are actually logging in and doing things. So you can see when it's weekend, at least, right? Then it's in the middle. I think 14 and 15 October it was weekend because we're lower user base. I also expect that people are actually running some jobs, right, in the weekend to do some things, right? It's allowed, but at least we can see the usage. So so this is only one lab. So we also have radio. You mentioned that radio. I asked this morning. It's like 200 active users. They also use the OSVD, the secure virtual desktop, and they have around 200 users. And radio is actually one instance, right, with a lot of projects in there, the Data IQ product. And here we actually have a lot of copies of the infrastructure and access that in parallel. And we have about, I'm not sure if you can read it, I think we're slowly growing towards 200 active users on the day. Yeah.
That's only Databricks, huh?
That's only Databricks, yeah. And you can also see the activity of the labs. And from the 120 labs, actually, what is it? Almost 50 are being used. That is also a bit sad, right? That we have a lot of labs deployed. They say, oh, we want to onboard on one lab. We say, okay, we do that, we automate it, and nothing happens. Yeah, but it's also people are working on the legacy environment and needs to transfer and need some new features. Yeah, it's always a balance with features and functionality. Yeah, so I hope that will also be we can close that gap about the product that we have deployed, the amount of labs, and that is actually being used. Yeah.
I'll just shut them off and see what happens.
Yeah, save some money. Yeah. That was a bit of the story about the usage of OneLab and where we are now. And we want to maybe close with the key takeaways to make this a success. You want to say something about it?
Yeah, maybe obvious, a good balance.
Oh, I shut it down.
It works. A good balanced team of engineers, that might sound very obvious. Don't always go for like only senior engineers like Alexander, but have a good balance because there will always be movement of people around. So also attract young people or junior engineers to come along. They have fresh ideas and they're young and vibrant most of the time. Maybe another one, understanding the playing field. You're very easy to make the assumption that what we do is good and people will use it. Data science was very eager to use Databricks because they were familiar with the tool and they're a little more tech savvy. They just want to go there. But if you work with people from risk, that's a more traditional department within the Rabobank, and they're working with Python, with SQL, Server Management Studio, and SQL, and that's their way of working. And they, I don't want to say reluctant to change, yeah, but they need a little bit more guidance. One important thing is the collaboration between business IT and architecture. We work agile, we have the agile framework in place, meaning we have business IT and architecture aligned in triangles and everything. Also begin with the end in mind. Think that it will be successful, that it might be big. Don't make a monolithic environment. That's the other thing. Be able to just throw it away when it's not working. And also allow early access. We have bright minds, we have good ideas. We think that we do it like the people want. And then you find out that it's not that way. So also have like a peer group or a focus group. Just give it to them. And just tell them it's not perfect. Just let them work with it. Gather feedback. And one very key point is that we are working with production data. And I always emphasize to all of the engineers, everything you do, have that security part at the back of your head. That's of the utmost importance. If we leak any data, in whatever way, we will be front page. Front page is nice, but not with leakage. That's kind of a no-no. I think that the monetary fines that you will get when you leak data are pretty hefty at the moment. And like what I mentioned also earlier, make it modular for extensibility. We had a very monolithic pipeline, and they tend to break. They're not flexible, so we kind of got rid of that and build a new, and that's where you also were the founding father of. Build a platform that's expandable, and more generic and modular. Yeah. Any questions?
Thanks for the presentation.
Welcome.
I see that in your slide you have a high code with Databricks and then low code or no code with the data equal. So basically, as I understand, let's say Databricks is for people knowing a lot about data engineers, but data equal is for domain expert who knows about the knowledge, the business thing, but not really about the data. But I think, let's say, from the data equal, the people who knows more about business, they can also, using the OneLab, they with their knowledge, they can build something which is meaningful. But what is the relationship between the data equal and then the Databricks there? if you, let's say, transform it from the data equal, let's say, first idea into the more professionalized Databricks or not?
Well, this
what is the balance?
Yeah, but first, this is what the architects think. The data IQ is the no code, and Databricks is the high code. I tend to differ a little bit. Also, people. Yeah, you can do a lot of high code in Databricks, and if you have like a small IT team doing a little bit of stuff in Databricks, it's also closer to not a no code environment, but people who are used to SQL Server Management Studio, and that's what they target as the no-code people, they can work in Databricks. But this is, from architecture perspective, this is how they see it, and I dare to differ. I differ a lot with architecture, but I think that's part of my job also. The thing is that the data queue is a little bit more engaging. It tends to be a little bit easier, and you will always have people who will never learn how to use Databricks. You will always have them. So you always need a tool like Dataiku in place. And currently, to my honest opinion, there is no proper Azure native tooling that covers what Dataiku can. Does it kind of answer your question, or?
Sometimes that the things that they have already created in that data equal will be professionalized in Databricks, like the first idea to there?
If they want to go to production, they should. And that's when there's an onboarding and people ask for Dataiku and they say we want to productionalize our solution, I always warn them. You can use Dataiku for data exploration. You can also write just Spark in there. Just you can do it. You can make the start, but you have some advantages of things that Dataiku does for you. But if you want to use the model serving platform, MSP, to productionalize your model, you have to do a little bit of rewriting of your code. So you have to follow those steps. There was a decision not to productionalize Dataiku or not having a Dataiku productionization effort.
Okay, thank you.
Yeah.
I think even Manolis helped, right? With.
Yeah, I was part of the team like a while ago. Yeah. I know.
So yeah, I was the one enthusiastically answering the questions. Because we're from the ABN, so we're doing exactly the same thing as you guys, almost. Sure. So of course we also use Databricks within the bank. I see you talk a lot about protecting the environment, right, through a virtual desktop. But Databricks itself, Azure Databricks, has some intrinsic data exfiltration risks because it uses services that needs outbound connectivity. So if you don't protect that outbound connectivity, then the service will break, basically. So how do you guys deal with that? Because, for instance, the Hive Metastore, that's one of those instances. If you allow your end user to use it, then they can exfiltrate data to their own private SQL servers, for instance. Is that something that you manage? Is that something that you build in? How do you deal with that? Because without breaking the database service.
Yeah, of course, that is the hard part, to make it work, but also to protect it as good as you can. You mentioned already the private endpoints. That part for Databricks is quite new, that you can actually hook up private endpoints, and it's quite hard because you need to log in, have a specific Databricks per region.
SSO,
so,
yeah.
Yeah, to be able to log in. So we haven't implemented that yet. So that means we have the VNet injection. So you have your own network, you inject there, you say, okay, no public IPs. Yep. And from there you follow the procedure like, okay, you need to allow this, allow that, allow that, allow that, and else it doesn't work. So that's what you have to cope with. The other hand is, of course, whatever happens, you should make sure that you log whatever is happening. So turn on the diagnostic settings. That means what happens in Databricks is being logged to the let's say the log analytics or offload it to some blob storage, and keep it there to be able to have a how you call that, a chain of responsibility. What happened? So that is required. The networks, you can say, okay, what is possible for the outbound connections? Yeah, make sure it's all routed through your firewall, and with the firewall you can say, okay, there's no connections to all these things, and incoming there's no connection unless it's from, for example, our OS4D environment. Yeah, so Yeah, so you still, of course, have to make it work.
Yeah, so one of the, but maybe we can talk later, because one of the caveats that you have with Databricks is that they need you to open up certain ports, you cannot on an application firewall close it off, so you have to do it on networking. But if you do that, then you'll basically disrupt or you'll corrupt your Databricks environment. So that's something maybe you can discuss offline, I guess. And then the other question is, that's also something we're facing a lot, is you took a lot of measures to secure your environment, but if, like you said, if you use Hive, you have a problem. If you use Git integration, which can be done through SSO, you have an issue. People can commit things to their code base. You talked about the private repository, of course, already. But do you not feel that you're basically trying to close off things, but you can never close off the last 2%, and you're frustrating the user experience for most of the people that don't understand it anyways, and the people that do understand it, the people that do understand it, they will find the holes anyways. Right?
Exactly. So, for example, what is now not possible is that from Azure DevOps you can have your jobs and the job trigger Databricks jobs, right? Because that opens up a whole world of possibilities for the end users to also get stuff out and put it in and put it somewhere else, because those agents are like full power. So that is functionality we don't have implemented yet. But of course we are looking into, okay, how can we facilitate that in the best way possible? Of course, within Databricks there are also workflows. You can have something next to the Databricks environment which can do scheduling and triggering. But it's always a bit of a balance to see what is possible. We do have Git integration because we say the lab is M for all. It can be thrown away. Make sure you always have Git, and Git is checked into the environment. In this case, Azure DevOps, you get it in there. So within Databricks, you can also say, okay, it's only possible to have this Git URL allowed. Also, next step, what we're also looking into is also for all the outgoing traffic. So now we allow domains like, okay, you can go to this Azure DevOps environment to also see if we can have this TLS inspection to see, okay, what's possible there.
But it's a balance.
Yeah, it's always a balance. It's always a balance. Battle, yeah.
All right, thanks.
I don't know how we are time-wise, but we can also answer the questions.
Yeah, let's
later on.
The last one.
Oh, okay. One thing I notice in my day-to-day is that moving from, let's say, proof of concept to an industrialized version is a very tedious and slow process. What kind of things have you enabled in one lab or maybe enforced in one lab to make this process a bit smoother? Because I assume you maybe make some sort of with Databricks you make some sort of model. This goes to that model serving layer you mentioned, I believe. Is there anything there that says, okay, you have to do this and that and this and that before you're allowed to go to production, or is it very flexible? Because we notice if you do more flexibility, everything takes longer in that part, but it's also balances, I suppose. But I was wondering how you did that.
It's a simple question. You think it's a simple question? No, it's a tough one. What we try to achieve, what you saw on premise is that there was no counterpart to productionalize. And now what you have at least the same environment. It's both Databricks. Yeah. You can develop with the global data platform, so there's no connection issues when you move to production. But still you have to do the scanning, everything. There's, well, it's almost legislation that you have to go through. But to make it as simple as possible, to have at least, not within months. It was months. If we can bring it back to a month or 2 weeks or something, then we struck gold. Instead of going from months to 2 weeks, we're getting there. There are bumps, and currently we have another product owner who's really working on that governance across the platforms. How can we seamlessly get that model, the code or the binary, towards the production environment with as least of bumps, as least bumpy road as possible? It's an epiphany that it will be super smooth, but as smooth as possible.
Yeah. And also from the tribe, the data science area, they're also trying to make standardized components, which try to facilitate that. So the internal MLOps component, and if you use that, you should be good to move to the next stage into production. Yeah, but we don't facilitate that. We don't have the manpower. Yeah.
Thank you.
Thank you very much. I'll have to.
Yeah.
You could just drop the mic. Now I'll give you 2 bottles of wine.
Here. I think we're all good, so let's have a little audio check.
You want to mirror it?
Yeah, not mirror, external.
I think that's how it is now, right?
It's mirrors right now.
Mirrors.
Wait, yeah, it's just mirrors.
So if you go to orange.
It's just the... Normally you can just do this.
You go advanced.
It's...
If you change the mirror for the...
Mirror, something. Stand up this way, there we go.
okay.
Yeah. Cool. Yeah.
Yeah, test.
Seconds.
Great.
Great.
It's working.
Hello, hello, hello. Yeah.
So, I think that we can conclude this day's talks with a very interesting, in my opinion, talk from Oliver and Wouter, which is about leveraging ML forecasting for enhancing the stability of the energy grid. Welcome, guys.
Thanks.
Yes. So let's talk about forecasting.
Ready?
And next slide.
Sorry, guys.
And then we have a few more seconds to let people come in.
Okay, it's working now.
Yes. Can we go back a few slides? Yes. So, first introduction. My name is Wouter Vuil. I'm a product manager data within SimPower. Background in engineering policy analytics. First as a data scientist, and then move to product manager data within SimPower.
And I'm Oliver Ford. I have a background also in data science, but also human-centered AI. I used to work as a freelance machine learning engineer at different companies. One of them was a whiskey company, which was quite fun. I used to work at Xebia as a consultant, and now I work at SimPower as a machine learning engineer, implementing forecasting models, among other things. Yeah.
Yes, so for today, first we're going to give some background on how the electricity network and the grid works. And then we dive into what is a good forecast and how we align our forecasting models to be in line with the business objectives. So, electricity grid 101, brief introduction. And so, in the electricity grid, we have a big challenge. On the supply side and on the demand side, there are a lot of things changing. So I want to see some hands of people who are having solar panels on their roof. Is there any? Yeah. And are there also people over here who have like a dynamic contract, like for example with Tibber, or other long-term contracts that you are challenging with if you should make a fixed contract with your electricity supplier, like taking a 1 year for which price and that kind of struggles? Is some of you facing this kind of challenges? No, everybody has an electricity company, right? Electricity. So there are now most of these electricity companies. They have gas-fired production plants, coal-fired production plants. But on the supply side, it's changing. So we have solar panels and wind farms, and now we have distributed solar panels because people have solar panels on their roofs. But on the same side, the supply side is changing. The electricity grid is also changing on the demand side. So the past we had combustion cars, but now we have electric cars. People have electric heating, electric cooking. So two sides, this whole machine, and you can argue that the electricity grid, especially the European electricity grid, is one of the biggest devices that that we as humans have built. Have to change rapidly, and we as SimPower want to play a part in that. So how are the electricity markets organized? So you have the long-term markets. So there are like deals for like multiple years ahead. They are really done when you're setting up a wind farm in the North Sea. Then you make like a deal, you hedge your income streams. But there is also like this day-ahead market, and every day the prices are cleared, and there is an hourly price on what the electricity price is going to be. And sometimes in the news you see these stories like about negative energy prices, and this is in this green part, the day-ahead prices. And even this is like an hourly basis and a day day ahead. But we also have another market. It's called the day-ahead the intraday market, and then it's within the day. There you can buy and sell your electricity based on some last-minute changes. For example, if the weather forecast is not that good and you are a solar farm owner and you think like, no sun, let's sell some of my initial load. But besides that, we also have the balancing markets, and that's where we come into play. Because the electricity grid is an AC grid, alternative current, and in Europe we have 50 hertz. So that's on all your devices. When you look at your laptop adapter, you see these small letters, and they're saying 50 hertz. So this is this number. And so electricity grid always needs to be in balance. Input equals output. And if it's getting out of balance, less or too much energy popping in or too less popping out, then it's getting out of balance, and this 50 hertz is moving. And when it starts to move, then the balancing markets come into play. Because if it moves a lot from this 50 hertz, then devices will go down and we go dark. So there are a lot of people that are preventing this. And one of these mechanisms to prevent this is using balancing markets. So in these balancing markets, you have a lot of them. And over here on the top line, you can see the frequency. And when it starts like deviating downwards, then there are some markets that devices are turned on and off, or some extra gas-fired power station is like putting some extra gas in it, so it's providing some extra electricity to the grid, so that the 3 electricity balls can be put back in, and so to get it back to 50 hertz. So there are different markets into play. First, like for the first hit, some for the second hit, and even one for the third hit. And there are some restrictions.
Can you maybe explain how the frequency, the voltage, and the current, like how does switching on the device change the frequency? How does that work with the voltage and the current as well? I thought the frequency was just like with an AC generator, how many times the different magnets, like the magnet goes to the coil.
Yes, that's correct.
But how does that change when you add another device on it? Doesn't that just drop like the voltage and the current?
So what has happened? So you have this big, especially traditional power plants. They have these big machines running, and they are running at 50 hertz, so 50 turns a second. And so the electricity, or I'm not going to want to go into too much detail, stays in line with this spinning wheel, but with if you put more electricity in your grid and you don't use it, then this frequency is increasing, because a lot of perhaps I can move it from. So this is like traditional one, but if you have like a solar panel, it's all in DC currents and it's inverted back. Yeah. So then there is no nudge. If then you have no inertia in the system because it's just artificially put to 50 hertz. So if everybody starts using it, perhaps I can best explain it with this picture. And then I definitely have to move on. Perhaps we can talk it otherwise. We can talk about it later. So if some power plants are not able to produce anymore, then this inertia is lost. Let's call it like that. And then we have less electricity to put in, and then the demand side is still the same, and then you get a switch in the frequency. But let's go over it later. So we have different markets that can play a role on the in this, based of your first aid, second aid, or third aid. And how is this done so far? I already explained it a little bit, but you have the big TSO, like the ones that owns all these towers, these electricity towers next to the highway. This is called, in the Netherlands, it's called TenneT. And then you have the BRPs that are like the Eneco and the Vattenfall, and they own power plants. So that's how they do it. And then when there's a disturbance event, Eneco TenneT calls like, hey, Vattenfall, can you spin up some extra power plants or put some extra gas in it, and then we're back to normal. But there's another side which you can do. You can look at the demand side of the electricity grid and just ask greenhouse owners, can you please turn off or on your lights in case if we have this disturbance event, and then you solve it via the demand side instead of the supply side. But what is needed, these greenhouses, this individual greenhouse owner does not have the knowledge to go to TenneT and work on this whole electricity market with 50 hertz and that kind of stuff. So this is just a greenhouse owner who wants to do their thing. And then the SimPower comes into play, our company, and aggregates all these small greenhouses or other industrial sites all together and bid them as one bid to the main actor, in this case the TSO, TenneT, to help in the disturbance events. So what are kind of our customers, as we are an aggregator, like the greenhouses, we can turn on and off the lamps, paper industry, data centers, crypto miners, furnaces, all big industries that have that uses a lot of electricity, but also have some flexibility, like to turn them on and off, because some devices are never allowed to be turned off. But so there should be some ability to turn them on and off. So what we do when we want to move to a truly sustainable electricity grid with renewable energy and electric cars and etc., we need this flexibility to deal with all the volatility, and then SimPower can play a role, and all these aggregators to turn on and turn off the resources when needed. So that's in short what we do within SimPower. So now we're going to talk a little bit about why do forecast matters, what makes a good forecast and why it matters. So as a part of the data team, we support the analyst with forecasts to make the best possible bids. So what is the best possible bid? So you have the TSO, the grid, let's call it like that, the TenneT. Then we have us, the SimPower, and you have the customers that we are aggregating. But the TSO, they want to know for certain upfront how much flexibility can I get in case of disturbance, because I don't know upfront when there will be a disturbance, but I want to make sure that the people that will say that they are on call can definitely facilitate me. And then there's us. We want to facilitate this truly sustainable electricity grid. And then there's the customers. They just want to slap it all down to monetize this flexibility. Because I have this lamp as a greenhouse owner. I'm happy to turn it off a few times a day for a few seconds. But yeah, if I do that, I want to get some money for it. So what we do within the data team is to make sure that this part, the amount of electricity that or amount of capacity, let's call that word, let's use that word, is accurate, and that TSO can trust us that when we say we have 10 megawatts available for you at this time slot, then you can trust us, and then when there's a need to turn on and off, then they can definitely do it. And they and in return for that, they pay us money, and we also help the analysts to what is the best price to put them in. For example, there are a lot of factors that can influence the price of how valuable this flexibility is. If it's a really if it's a very, very uncertain day in terms of weather events, then the prices are higher because there's more need for flexibility. So, what is a good forecast from a product manager perspective? So we ask ChatGPT, and it's a good forecast. A good forecast is an accurate prediction of future events or conditions based on well-founded data analysis and expertise. Now we're done. And so that's the presentation. Thank you for listening. No, but what we want to do with this next 20 minutes is to show you our journey on figuring out what is a good forecast in our case. So it's we don't say this is a perfect answer. This did work for us, and I just want to showcase our journey. So the bottom line is there's a lot of iterations and a lot of feedback with our users. So first we had business metrics, optimize the model, evaluate the business metrics, get a user feedback again, and then update the metrics. So it was a continuous process, and our metric for success was changing all the time. Because unfortunately we don't live in a perfect world, and the model is not 100% accurate. So that was our biggest approach, and that's also things that we're going to highlight a lot of time is, just start, iterate, get a lot of user feedback on if it's good to get yes or no. So from a business perspective, there's a lot of things what makes a good forecast. There are a lot of nuances, and that are unable to capture all within one metric by the model itself, like for your loss function, but also to explain to the user. So there's this complexity of fines that when there's uncertain weather, then they want to have the model behave in a certain behavior. And we try to measure that in a certain way and put that as an extra metrics. And then we also had a metric to check for like user knowledge. For example, this last minute call by the resource owner, like, my resource is broken down, I cannot help you anymore. So then analyst has to adapt their bits. So the model was not taking into account that kind of information, this last minute calling. So the model will probably never be able to get all this information. So we try to measure that as well. And we had strategic targets that the analyst and the company valued consistency more than perfect results. So we had all this kind of different nuances. We wanted to measure those as well as like what is a good forecast. So we had like, we didn't have one perfect thing that we can optimize for due to all these business nuances and objectives that were very complicated to put into one metric. So what we ended up is that we compared what was the forecast error compared to the mean absolute error of what the analyst eventually offered and what we forecasted. And we just look at the deviations, on what level do we and analysts agree or disagree. And by just looking at that, we don't judge the model if it's good or bad, like what is the best possible bit, but just as a Kickstarter for a conversation. So if we and analysts start deviating, or if it's get above 100 or a lot of below 100, then it kickstarts the conversation, or it's trending downwards. So the analyst is trusting the model less and less and less and less. So it's not perfect per se, this is the perfect model because it's the highest accuracy, but just is the user happy with the current model? So that's a different way of looking at it, comparing to a perfect accuracy or 100% accuracy or certain loss function. And for us, there was an advantage. It's a single metric, easy to understand by the business, and it was only a monthly basis, so we can just go every month to the user, like, are you still happy, yes or no? And we see that you're using the model less and less, or more, or you're disagreeing. So one key takeaway from a product manager point of view and a product point of view is that each situation asks for specific metrics, and just keep it simple and just start doing. And that's from a product point of view what worked best for us. And of course, a lot of iterations with the users. Now I'm giving the floor to Ollie.
Okay, so I'm going to talk about how we actually made this happen in terms of forecasting. I'm going to talk a little bit about the complexities of demand forecasting. I realize I don't have so much time, so this is going to be very fast. I'm going to talk about some modeling strategies to overcome these problems. Then we're going to talk a little bit about how we evaluate our systems so that we can trust that these things will continue performing over the course of a year. And finally, we're talking a little bit about how we can optimize our forecast to be in line with the stuff Wouter has been talking about, these business objectives, and how we can kind of basically take it further than just accuracy, essentially. So, complexities of demand forecasting. There are kind of a couple challenges when we're forecasting individual resources, is essentially that they're very, very diverse, right? So every industry is different. Even the resources within a particular industry bracket are different as well. And so it basically means that every industry, every resource is a different snowflake. And we have to figure out a way to kind of deal with all of them at the same time and get something useful, some useful forecasts from these. Turns out, actually, that we can categorize these different resources into roughly 4 different types of categories. We have smooth resources, so these are resources that are very consistent. Wouter gave an example of crypto miners or data centers. We have erratic, and these are resources that are the variance is high, but they might be a continuous signal. So the actual, like, the variance, the value that we need to forecast is a little bit uncertain, but we know that it will be active. There's lumpy. These are kind of like a little bit of combination of high variance, but then sometimes there are periods of zero demand, and this is harder to forecast. And finally, we have intermittent, which are essentially periods of inactivity that are undetermined. So we don't know how long it's going to be inactive, and then when it will start up again or when it will shut down. And this can be due to production schedules or something else. And you can understand it's very difficult to forecast something if we don't know when it's going to start or when it's going to stop. So varying degrees of difficulty with these different categories. The next thing that we actually have to deal with is that over the course of a year, a particular resource can actually change in how the demand profile. That's what I like to call it. So these images here, you can see this is a particular day. We might have at the beginning of the day higher demand, and then a little different dip in the afternoon, and then higher again in the evening. But then depending on the time of year, this profile changes, and we have to actually make sure that our forecasting models can handle this nicely. Finally, these resources all differently are affected by different external factors. So, for example, energy prices, the political environment in that particular country that we're forecasting for, and of course, the weather. So, all in all, these resources are dynamic. They vary with time of year, with production schedules, external factors, and these are all things we have to account for in our forecasting models. So, how do we do that? One thing, one approach we can do, especially as we are an aggregator, we can take many of these resources together for a particular category. So let's say greenhouses, and we can actually aggregate these together as a particular group. Once you aggregate, you actually get a much nicer signal to forecast. You get rid of a lot of the variation that your model might kind of like jump on and try and like learn these random noise. And instead we get the kind of more trends in that data. And that's actually what we care about. We'd like to know at a portfolio level, what are the trends in our portfolio? So that's one tactic we can use to kind of remove these intermittent and lumpy resources out of our data sets and essentially give our model an easier time. The second thing we can do is sometimes it's not possible within a particular company to give forecasts at a particular aggregation level, right? If we aggregate for an entire country, but we need forecasts at the individual resource level. But how do we still benefit from this aggregation? So one thing we can do is something called hierarchical forecast reconciliation. It's a bit of a mouthful, but essentially what we do is we still do forecasts at these different aggregation levels, and then we do a little bit of matrix multiplication to make sure all of these forecasts agree with one another. And we can get some benefits in accuracy at different aggregation levels by doing this. It depends a little bit on your use case, but it is a nice option to use if you're restricted by what aggregation level you need to provide to your end users. Finally, something I'm a big fan of are these global models. Essentially, in one sentence, global models are models that have been trained across a wide variation of resources. Instead of just one model per resource, a global model will learn to transfer learning or take learnings from one resource and apply it to another. It's also a really nice solution if you have the cold start problem. So if we introduce a new resource into our portfolio and we don't have any training data, we can use a global model to just forecast it straight off the bat and we don't have to worry about it. All right, so in summary, basically depending on your problem, you can combine or stack these different strategies to make the problem easier, but at the same time also create more accurate and robust forecasts, depending on which options you take. How do we make sure that we trust our models? And this is very important, especially if we're delivering stuff that our bidding team will use, and we could technically incur a lot of fines if we do this incorrectly. So we need to make sure that we can trust these models over the course of their life cycle. Basically, backtesting, right? This is cross-validation for time series. Essentially, you basically take your model, you train it on a historical period, and you shift it over this historical period, testing on different slices into the future. And that way you kind of slice your test data over a period of time. It's essentially like as if you were to run your model in the past, as if it was running in production every day or every month or something. What this means is that we can actually evaluate our model over the course of a year, and we can see how it performs for the different seasons, like I was talking about earlier. With different resources, they change over the season, so we need to make sure that we're getting the same accuracy across the seasons, and also different weather conditions, these kinds of things. So it gives us a lot of confidence in our model. This confidence is actually something that we can communicate to our stakeholders, and then we sell them, hey, yeah, it's going to perform like this in February, and then a little bit worse the next month, but then better again. And they see that happening. That gives them a lot of confidence in us, and that we know what we're talking about, which is always great. Finally, how do we go beyond just accuracy? And how do we align our forecasts with the business metrics that our product managers work so hard on defining together with our stakeholders? So to give a little bit of context, our goal for this project was to make sure that our forecasts would adapt to the current market conditions, but also deliver as much business value as possible. And what does this mean? Wouter already mentioned it a little bit, that we get fines if we say we have more capacity than we actually do. What this means is we have essentially an asymmetrical problem. If we offer too much, we get fined a multiple of that capacity that we offer. So that means that even if we were to forecast like just one tiny little bit over, we would get fined like 3 or 4 times the value of that amount. So we really have to be very cautious in what we forecast. Another thing that's very much like business-oriented is that we forecast at the hourly level, but we're evaluated on these fines at the minute level. And you can understand this as we have a sort of a step function. And then even if we were to perfectly forecast every hour what the value was, we would still actually get fined. So we have to actually forecast on purpose under to make sure we never get a fine. And finally, there's a lot of uncertainty around what the best strategy is, and if one strategy will actually work across the year. Again, this whole dynamic thing. And we need a way to evaluate which strategy will work, and we need a way to do this quickly for many different parts of the year. So we did some initial investigations, and we found that actually the hyperparameters that we need for the best model were changing. This is what we guessed. So we needed a solution that would allow us to dynamically change hyperparameters over the course of the year to accommodate for differences in the market volatility. The second thing is we found that optimizing directly for the business metric at the level that we were forecasting, the resource level, was essentially making the forecast way too conservative, actually. And so essentially leaving money on the table. We didn't want to be too conservative because, yeah. So our solution actually had to implement something that was optimized at the level that we were doing the bids and should adapt over the course of a year. So the solution we actually came up with was to optimize the business outcome at the level that we bid at, but we don't actually optimize the models for this particular business metric. We still use our normal loss functions, but we use the business metric as a way to select the hyperparameters and the models that like candidate models and candidate hyperparameters for a particular experiment. And then what we do as well is we adapt our forecast to seasonal changes by essentially every day we retrain our models. We have a validation set that we use, and then based on the current market conditions and in comparison to the business metric, we pick the models that perform best in the current market conditions every day. And then as we move into the future, we're continuously updating, and so that in summer we can be a little bit more cautious, and then in winter we can be a little bit more aggressive. And I realize the time, I'm 2 slides away. So what are the outcomes? Yeah, great. So we built something that was highly scalable. The fact that it's dynamically optimizing itself every day essentially means that even if we were to introduce new resources or put this into a new country and go live there, it would just happily start optimizing for that particular use case. And we could just have a little look, it'll probably be fine. The second thing that we're really proud of is actually that we had about a 30% improvement in this business metric alone with this setup. Of course, we're optimizing for the business metric, but the end users are happy. They have to touch the forecast a lot less, and overall that means they have more time to do other stuff, which is one of our goals. And finally, because of all of this dynamic optimization that we do, it means that we can quickly test out a whole range of different models, hyperparameters for a particular problem, and very quickly get an answer. And this has saved us a lot of time instead of doing manual experimentation. So to wrap it up, as Wouter told us, every situation asks for a specific set of metrics, and you should just keep it simple and start. And from a more technical point of view, you should select the most suitable model based on a metric and test scenario that is very similar to what your business objectives are. And we'll take questions. I think we have 10 minutes, so that's it from us. Thank you. Thanks.
Thank you very much. Questions?
Can you maybe share a bit the libraries, the technology that you used for the modeling part, like which libraries, maybe some MLOps pieces?
Yeah. So we use Databricks. I kept this out on purpose. I didn't think it was that interesting, but sure, we can talk about it. We use Databricks. We have a setup where we spin up ephemeral catalogs, and we can actually use our entire production data for testing. So that speeds up these iterations very quickly. We use LightGBM is a great model. We also use Profit and some other ones. Some of the sorry, you wanted to know the libraries. So like GBM, Profit, we do a bunch of our own in-house data engineering. We have our own stuff that we built.
Any specific MLOps libraries, maybe? Like managed models?
Yeah, we do that all ourselves. We built everything ourselves. We used to use MLflow, but the setup we have now it's actually much cleaner just doing it custom. Yeah.
Yeah, I have two questions. So once you said like you use hyperparameters to tune your model on daily basis, right?
Yes.
So how frequent is that? Like you have to retrain your models based on new data. Like what is the frequency that you're getting new data?
Every day.
Every day. Like, and no, not that. Like every day, what kind of data you get to train the model? So basically, let's say the weather forecast. You need
Yes.
the weather forecast, right?
Yes.
So do you get the weather forecast every like hour or one day at a time? Like how frequent it is for intraday kind of situations?
So are you asking the frequency of the data
Yeah, exactly.
or how frequently we get the data?
How frequently you get the data and you retrain your model with the new parameters, like, you know?
So we create new models every day.
Okay.
And for example, weather forecasts,
Yeah.
we get forecasts from other companies
Yeah.
for the next 10 days at the hourly level, right? And we also forecast for the next 10 days at the hourly level.
Okay. And the second question is, what is the incentive for the customers, like the greenhouse
Yes.
things and the plants and all those things? I can understand from the TSO perspective, it's their benefit
Mhm.
to do this so that they can maintain the balance.
Yeah.
But what is the benefit of those customers that you connect to? Like,
Yeah.
I'm not able to understand maybe. Yeah.
Yeah, so the way I like to think about it is basically we pay the customers every day
Okay.
for the option for us to turn off their lights. And how often we turn off the lights can be once a month, maybe twice a month. And so what that means for customers, essentially, they reduce their energy costs, right? We give them some amount of money per month, they take that away from their energy costs, and maybe they have to turn off their lights once a month. That's essentially what's going on. It's a win-win. We also help balance the energy grid, which is something that we're doing, which is needed now more than it used to be because we have green energy, right? So we don't always have the sun shining, and that causes fluctuations in the grid a lot more than if we just had a coal power plant lasting all day, every day.
Thanks.
Thanks for your very interesting presentation. I was wondering, how about unexpected events, like natural disasters or something that the model naturally cannot predict? Does it even happen? And what do you do then?
Yeah, so a good example actually is for very large industry, they have production schedules. And it could be that they go from max capacity to zero within an hour or a minute. It's essentially a natural disaster or unexpected event, right? And these cases are very difficult to deal with. And I kind of mentioned that aggregation is your friend in these cases, right? If you aggregate enough, you can smooth out these massive dips. And also you can, so the answer to the forecasting model is not going to know about these upcoming, like that. If we could predict the future like that, that would be great, but that's unfortunately not the reality. So we also communicate this with our stakeholders and say, like, look, if these particular resources are very large and they're very erratic, there's not so much we can do about it. We can try and aggregate a lot of that erraticness away, but if it's like for a particular portfolio and it's half the portfolio is a really erratic resource, there's only so much data manipulation and grouping we can do to kind of like smooth that out. So I hope that answers your question.
Yeah, it does. And does these kind of things could impact your model because you train your model daily based on data? So can you cut that out somehow?
Yeah, of course, everything that we train it on, it's yeah, especially, with lag features and stuff like this, if some event happens today and then we train it and then it might only kind of appear in the data set tomorrow or the day after, because if you're forecasting 10 days in the future, you can't know what's going to happen. Yeah, so it does affect it. And we do see that there's a bit of a lag effect in some of our forecasts with events. Like we'll see the event appear a little bit later, but there's not a lot you can always do about that. So, yeah.
Perhaps as a nice example for disasters, or if it quantifies as a disaster. Like last year in 2022, we had the situation in Ukraine that has a big influence on all the electricity prices, and also for a lot of business cases for production sites to be operational due to the high energy prices. So for certain countries or certain resources, energy prices were not an issue. They were just operational and they just only depended on the weather, for example. But now with this super high prices, then there's a difference between extreme and super high. So then, yeah, there's an external data source needed to. So we have an extra data source in that can explain some of the behavior in the past.
Yeah.
So that, of course, is also. But this is a continuous thing going on, and there's always external data that you have to chase.
One of the reasons we also forecast retrain every day is we actually recreate our data set every day, because sometimes a resource will drop out will either drop out because the price is too high, so it doesn't make sense to include those in our historical data either. So we actually dynamically create a data set every day, retrain it, and then that way we can handle. If you have a growing portfolio, it's not a trend in your data. It's just you have a bigger portfolio, so it doesn't make sense to kind of forecast that as a trend. Lots of questions.
Yeah, just one last question. I was curious to know on what's the time period that you use to train your models. It's like 1 year, 1 month, 1 day?
Whatever we have, we'll take it all.
But do you train, you have a model specifically for each industry that you provide energy for, or just for the different assets that you have?
Yeah, so like I was talking about this hierarchical, we have per asset, we have models. We also have models per group. So grouping for greenhouses, and this kind of stuff. Yeah.
Thanks.
One more question, just out of curiosity, I'm just wondering if you analyzed in which other countries or regions these kind of solutions would make sense. I mean, like different climate or different other conditions.
Yeah, we have a whole team for that, the market strategy, and they're busy investigating all sorts of markets all over. We call it pan-European, like we're currently in Israel and Greece, a whole bunch of different countries, and we're evaluating. Sometimes it's difficult just because of the politics in that country, and they don't currently support this kind of operation. Other countries. Yeah, it really depends. So yeah, yes, I guess is the answer.
Maybe a weird question, but I was wondering what is the weirdest sort of data source or data set you're using that you wouldn't expect to be part of a model that would predict such a thing? Like you were talking about, for example, the political situation, or maybe events that also happen because of politics. Maybe news is being monitored or something like that.
Yeah, so. We don't currently use these, but for example, if we did investigate, greenhouses, right? So these are producing plants. You actually can get data sets where they have ground temperature and all of these other things. We do actually also forecast crypto miners. So the price of Bitcoin, including that in your model, actually would increase your accuracy. So I guess that's a bit weird. We're not actually on the stock market, but we can use kind of stock market data to improve our models, which is...
Perhaps I have one nice example. It's not that we didn't include it, but there were some talks about that. Is the bird migration. So they tag birds where they're at, and if they are all flying to a certain area, sometimes the wind farms in the North Sea are shut down or turned off into a certain area. So that has an influence on how the electricity is set up, but this bird migration is not fixed, and there's wind, but they track, you have subscriptions models to this tagging of birds, and you can see are they nearing the North Sea, and are energy companies adjusting their wind farms based on that. We didn't put it in.
No,
there were talks.
We had
the amount of events that you have is very low, so then you can argue how good it is.
How worth it is. Yeah. There's always okay.
But it's
add it to the pipeline and ingest it. Is it worth it?
Thank you.
So I think I can have like 2 hours of questions for you, but I just get to a little bit. One of the things, like, how many companies like you operate in this market, and like how much? It's not start a bit. How much money is there in this market? Basically, also the reason why I came to this question is like you're saying, okay, we're predicting 1 hour, hourly. But the intermittent energy market is priced for 15 minutes in advance, right? If you buy or sell the energy. So I was thinking, like, okay, if there's like more money in this market, you can probably like add compute power or something to that, get more like higher interval predictions, something like that. Is it like? So are you like the first player in this market because we're the biggest green energy market now in the world as this, or how does the market look?
It depends per country. So in the aggregator role that we have in Finland, we were the first. In Greece, we are also the first. But in the Netherlands, the market, this balancing market and this distributed demand-side response is way more mature. So there are like dozens of them, and of course in in these markets like Greece, this role is still only played by the big energy companies that control a hydro plant. So in some countries we are the first, some are we not, but it happens everywhere across Europe.
So it's basically an open market, free market for players to enter and to exit. So how do you make your money then? Like, what's the
USP?
Okay, what?
What are you?
No, not so much the USP, but like, how do you like, where do you get your revenue from?
So in this,
because you have to pay the clients in order to enable or disable their energy.
It's a revenue sharing model. So we so there's this X amount of euros, and we take Y% of it, and then the rest goes to the customer.
Oh, it's just the energy grid pays you for it.
Yeah. So
okay.
energy, and they get their money via our taxes.
Okay, and you don't make money by trading the energy on the open market.
No.
That would be maybe an extra.
We're not an energy trading company. No.
Okay. Well, thanks.
Maybe there are more questions, but I think we need to wrap it up for people that are also joining remotely. Thank you very much for being here. Very interesting talk. Thanks everyone for being here today. I think we can continue outside for some drinks. I wish you enjoyed it and hope to see you again soon.